at Higbee's last night. A little folks will be strolling in a little bit later. So hopefully. We got some empty seats down here in the front. Prime sitting for asking questions. You might get the microphone quicker when it comes to question time. Did anybody have any meaningful connections last night or during the day? Did anybody was able to connect with the government office they wanted to speak with, another company, industry folks that you think is going to lead on to another conversation? We got any hands? All right. Okay, I'm going to ask you guys when we're swapping out panels if one or two of you want to share what those connections were in the sense, if it was meaningful to you. And there was a lot of questions yesterday about, hey, how does the Army Application Lab work? And so I'll explain a little bit more later at the end of the day, but next month, 25th February, around 2 p.m., and this will be pushed out on our LinkedIn and social media pages and all that, but we do a kind of a seminar, 15-minute seminar. The corporate ventures team puts it together. This is how Army application works. This is how we work with companies. We like to work with startup companies, trying to navigate the Army, get them connected with DoD. We want to show traction. We want to help you guys out. We want to help you guys break down barriers, get into those offices, get into the CDIDs, get into those program executive offices, or just find those right Army customers to help you excel. And so we'll explain how Army application works. That way you have a better understanding of how we can help you. We're a very boutique operation. Versus like your DIUs and your AFWorks with billions of dollars. But we do great at connecting. We're almost like a super connector at Army Applications Lab. But let's go ahead and get this thing rolling and get it kicked off. So this morning, let me introduce you to our Deputy Director at Army Applications Lab, Colonel Robert Clay McVeigh.
Thanks, Sam. Morning, everybody. Before we get started, I'd like to spend a few minutes to discuss the role of the Army Futures Command within the larger Army enterprise. Army Futures Command was established in 2018 here in Austin, Texas, and it seeks to transform the Army to enable it to fight and win our nation's future wars. Our commanding general, General Rainey, likes to say that we don't necessarily need to get everything right for that future fight as much as we need to make sure that we don't get it wrong. And if you hang around AFC long enough, you'll discover that we like to talk about transformation that occurs within 3 different time frames. That first, which occurs from present day to 2 years out, is what we call transformation in contact. And then from 3 years out to 7 years is what we call deliberate transformation. And then lastly, from 8 years and into the future, say 2040, 2050, the date is not as important as the idea that it's the long term. That is what we call concept-driven transformation. So let me kind of quickly describe what those 3 transformation periods do. AFC uses different approaches to influence each of those 3 time zones. For concept-driven transformation, that's the one that's the furthest out. That's driven by our understanding of what the future operating environment is going to look like. We ask ourselves, who will be our major adversaries? What challenges will our economy face, and what challenges will our nation face, and how and where we might expect to fight? And then we ask what technologies might exist that the U.S. could leverage to create additional strategic advantages. For that deliberate transformation period, which is 2 to 7 years into the future, we focus primarily on government budget cycles. Each year, the Department of Defense, with each of its services, presents a 5-year plan with the best information that they have to date. And then each year, that 5-year plan is revisited. 1 year falls off, and 1 year is added to the end. So we work each year 5 times before Congress appropriates the funds in any given year. For example, right now, the Army is developing its plan for 2027 out to 2031. The Army Applications Laboratory is focused primarily on the nearest of those 3 terms, the transform in contact period. As our director, Dr. Purley, stated yesterday, AAL seeks to accelerate development to deliver capability into our warfighters' hands within 18 to 24 months. And that's what we focus our time on primarily here in the Army Applications Laboratory. And this is what we do every day, and we hope to achieve through this VERTEX event. So the topic that we've all been gathered here today to discuss is advanced autonomy. And I feel strongly that the conversations that we had throughout yesterday and into today will inform all 3 of AFC's transformation timeframes. Assembled today, we have representatives from our tactical formations, our requirements and concepts writers, our scientists and our engineers, and our acquisition professionals. With industry's involvement, we can help shape the direction that the Army needs to head as it relates to autonomy. AFC is the Army's lead for human-machine integrated formations, and General Rainey is the biggest proponent for that change. For as long as I can remember, since joining the Army, we've talked about how robotics and autonomous systems will fundamentally change the nature of war. We've seen capabilities in robotic systems that are incredible. As a young second lieutenant deployed to Kosovo, I was responsible for 2 of the Army's 4 Panther prototype mine rollers. The Panther, if some of you know, was a teleoperated Abrams chassis with no turret, so it could move pretty fast, but it didn't have all that weight. Attached to its front were 2 9-ton mine rollers. I remember one particularly snowy day in Kosovo, my platoon sergeant and I, with no one around, conducted operator-level maintenance. With large smiles on our faces, we plowed donuts in our snow-powdered makeshift motor pool. And as the snow continued to fall, we walked away satisfied no one would know what we had just spent the morning doing. Back then, much like today, teleoperation was always just going to be a bridge to full autonomy. Autonomy was just around the corner. This is over 20 years ago. It's always just been 5 years away and about to make its way into our soldiers' hands and into our formations. Now it's 2025, and we're still living under that same promise. Just 5 more years, and fully autonomous systems will be within our formations. But this time, I think it's different. Perhaps this morning you crossed Brazos or 8th Street on your way to the Capitol factory. You may have spotted the white, shiny Jaguar SUV equipped with LiDAR on the roof and cameras above each of the 4 wheel wells. That pimped-out SUV is part of a developing rideshare system that is about to open for Austinites, like it's already done in San Francisco, LA, and in the Phoenix area. Autonomous technology exists today within the commercial space, and it's ready for the Army to start experimenting with it and within our tactical formations. We know it's not perfect, but we need to start accelerating the change. Last month, the Army published a plan for its Transforming Contact 2.0 initiative. We call this TIC 2.0. The Chief of Staff of the Army, General George, described TIC 2.0 at the last AUSA conference. The Army has designated some of the units. They're light, they're heavy, they're armored, they're mechanized, they're mobile. Infantry armored brigades, divisions, active, guard, reserves, conventional, unconventional. These forces are the Army's experimental test units that are designated to be able to try new formations and commercial off-the-shelf technology in the hands of the soldiers and to see what works and what doesn't work, and then to present to the bigger Army a decision if something has catastrophic success. Just 2 weeks ago, AAL engaged with in-depth discussion with 2 of these TIC 2.0 brigades who were seeking to leverage cutting-edge, state-of-the-art technologies to address their pressing warfighting challenges. These units recognize the potential of the commercial space to provide innovative solutions, and AFC is well-postured to facilitate their access to these technologies. One key area of focus is advanced autonomy. The efforts that we undertake today will have a lasting impacts on AFC's strategic plans, again informing all 3 of AFC's time horizons. Building on the momentum of this VERTEX event, AAL will write and release a solicitation, as Dr. Purley said yesterday, to develop innovative solutions that can be integrated into our formations. We envision collaborating with the TIC 2.0 units to co-create some of these solutions. The discussions you've had so far and those that we will continue today will deliberately shape this solicitation's content and scope that we'll send out. We want to hear from you. What's feasible? What's possible? What are the specific asks that we should ask you to drive meaningful progress towards delivering real autonomy and make our formations better? Let's not just move the needle, but let's achieve some results that forces the bigger Army to make some decisions about what it plans within that deliberate transformation time frame, those budget years that we're working on. To ensure that we capture all your valuable insights, we've been taking notes throughout our breakout sessions. However, we also want to provide an opportunity for you, or anyone else for that matter, to share any additional thoughts or ideas that may not have been discussed during our smaller group discussions. To that end, AAL will issue a request for information inviting you to submit any further information you may like. And we'll send you the direct link. I think some of you saw it yesterday in some of the breakout sessions, the QR code with instructions on how to provide specific one-on-one information. So yesterday we had the privilege of hearing from Brigadier General Troy Denemy from AFC's own Directorate of Integration. General Denemy shared a bit about AFC's vision of how human-machine integrated formations will affect the future of warfare. The Army needs to move away from one or two operators per autonomous systems to a one-to-many construct. He admitted that the Army doesn't have all of the answers and that it won't be the ones that develops the products or algorithms to enable human-machine integrated formations, but that it will come from industry with collaboration from us. He asked us to help make sure that the Army doesn't do something stupid, and those were his words. And while we'd like iterative design, we don't necessarily have the time nor the resources to iterate on poor design 17 to 18 times. After General Denemy spoke, we heard from our first panel, moderated by Major Will Ryan, consisting of soldiers who are actively working to integrate HMI efforts into their formations. It was interesting to me to hear how each of their perspectives on risk changed depending on what unit they were in. Sergeant Major Corey Wilkinson discussed 20th Engineer Brigade's experiments with a variety of technologies that could apply to the breach. The 20th Engineer Brigade was comfortable with assuming significant risk from their efforts because they were focused primarily on discovery learning. Captain Chris Chelson from the Joint Readiness Training Center, or JRTC, described how his organization is working to apply tactics and standard operating procedures to established HMI efforts. Chris is actively working to put HMI into the formation in a way that makes sense that units can use today. He assumes less risk than the 20th Engineer Brigade in that the technology needs to provide a positive return to the unit. Lastly, Sergeant First Class David Pace from the 75th Ranger Regiment described how every ounce and every cubic inch matter when going to a fight. He can't rely on the technology, then admittedly, he won't take it. The other big takeaway I had from this panel was the focus the soldiers had on the formation part of the HMIF acronym. Technology alone isn't sufficient to enable our warfighters. That technology needs to reside within formations that are trained and organized to ensure maximum effect to meet their mission requirements. And then Sergeant Pace left us with the somber realization that the Ranger Regiment, arguably the best of the best, is struggling to find effective semi-autonomous solutions, that these systems today aren't reliable enough to operate in GPS environments. They tend to break down. They're supplied at a quantity that soldiers can't get comfortable with. So I think we can do better here. In the second panel of the day, Mr. David Meyer walked us through his organization, the Futures Integration Directorate. On stage with him were three of his subordinate organizations from the maneuver support, and the sustainment CDIDs. The CDIDs, or the Capability Development Integration Directorates, are the Army's organizations that write requirements. These requirements turn into the specifics that our acquisition communities use when they publish their requests for proposals. Dominic Edwards from the maneuver CDID describes how HMI efforts can help us in the reconnaissance for both infantry and armored brigade combat teams, and that we could use both air and ground platforms. He emphasized the need for HMIF to conduct collective instead of individual tasks. Scott Werkmeister from the Maneuver Support CDID highlighted how his organization is looking to incorporate HMI efforts into the Army's engineer, military police, and chemical formations. And Lieutenant Colonel Karen Gale Diller from the Sustainment CDID discussed her efforts to incorporate HMIF into the sustainment commands from the Corps to the brigade level. She predicted that the role of the Army's sustainment organizations won't drastically change from what they're doing today. What will change will be how these units conduct those operations. During the Intuitive Interactions breakout sessions, I was struck by how quickly the conversation shifted from intuitive controls to the issue of trust. It became clear that intuitive control is inextricably linked to the level of trust that soldiers will have in their human-machine integrated efforts. Key questions emerged, such as how effectively will robots be able to understand and interpret intent? How will they adapt and respond as conditions change? Can soldiers understand why a robot is behaving as expected? And perhaps most importantly, can we facilitate efficient two-way communication between human and machine? Then, interestingly, during the autonomy override breakout session, the next room I went to, we spent most of our time also talking about trust. The group challenged the assumption that an override capability is always necessary. As General Autonomy noted yesterday, the goal is to achieve a one-to-many control. However, this approach raises an important question: how will the one monitor the many when an override is needed? Further discussion emphasized the importance of clear communication regarding the chain of command and then the succession of control for robotics and autonomous capabilities. In the third panel, during the PACT mission-oriented autonomous systems breakout session, industry communicated that we need to be able to communicate with autonomous systems the same way that we communicate with each other. Namely, autonomous systems should understand the task associated with intent behind it. To enable this, we need to use real data to train our autonomous systems and behavior models. For the survival of the fittest, hardening robotic systems for harsh environments discussion, there was an appetite for the Army to communicate its standards to industry to enable human-machine and machine-to-machine communication. Additionally, the room offered some critique to the Army to help better communicate and coordinate its experimentation efforts. The Army should clearly clarify in its SBIR solicitation if it wants a project to go demonstrate at some experimentation event. And then the Army should ensure that demo is coordinated across the entire experimentation enterprise. The last breakout session I attended, the Let Me Use the Stuff I Have, Integrating Autonomy and Legacy Systems breakout session, explored retrofitting existing equipment with applique autonomy kits. Industry experts noted that while this approach may be viable in some cases, it's not a one-size-fits-all solution. Regardless, the Army must consider the network requirements necessary to enable autonomy, whether through retrofitting or through other means. So thank you for all you've contributed to this effort thus far. It was a great first day, and I look forward to today's discussions and what that will bring. I'd now like to introduce you this morning to this morning's keynote speaker, Colonel Ken Bernier. Colonel Bernier is the project manager for Future Battle Platforms. Future Battle Platforms falls under the Army's Acquisition Office, Ground Combat Systems. That's PEOGCS, for those of you playing acronym bingo. Colonel Bernier has had a distinguished military career. He served as the military deputy for the Director of Ground Vehicle Systems Center in Detroit. He was the executive officer for the Director of Rapid Capabilities and Critical Technologies Office, RICTO, in Huntsville. He was the project manager for the Abrams main battle tank and has worked in the Pentagon supporting various soldier weapons systems. He is a career armor officer with experience across the Army's tactical formation. Ken holds a Master's of Strategic Study in the U.S. Army War College, a Master of Engineering in Systems Engineering from Stevens Institute Technology, and a Bachelor in Mathematics from the University of Maine. Please welcome to the stage Colonel Ken Bernier.
Thank you. Good morning. Well, that's really loud. I'm not going to lie. I panicked yesterday. I panicked when General Autonomy walked out and he was wearing that uniform and I was going to wear this uniform. I'm serious. We're institutionalized when we've been in the Army for a while, and that's, you do what your leadership does. I'm super happy to be here today, not because Ms. Link said, hey, Ken, I really need you to take this for me. I was going to be here anyways, because this is a topic that's super important to me. What is Future Battle Platforms? So my program office, we have the pleasure to transform how the Army fights. So, because I have the M10 Booker, which now will be the largest combat vehicle in IBCTs, and the RCV, the smallest vehicle in an ABCT, transforming how we fight. Along that lines, I also have the SMET, so we have all those questions later. So really what I'm going to do is I'm going to walk through some charts, and it's really to gain understanding. Like, what is it? How are we doing it? Where are we going? and how you can, insert yourself, or you can see our future. Because the key takeaway, there was lots of them before from Clay, but I exist in deliberate transformation, 3 to 5 years. 1 to 2, it's happening. Money's on contract, things are going to be delivered. I'm working through the fits of everyday issues. But that 3 to 5 is the constant transformation of the Army. It's like, okay, where are we going this way? Okay, we're going to go this way. Or we're going to go this way. Just how it works out, but it's aligning resources, which General Autonomy talked about, with industry and delivering capability. So with that, what is RCV? This is a complicated chart. So just bear with me, right? The name of it we like to use now from our CFT is Human Machine Integrated Formation Armor. So for the sake of this, I will refer to it as RCV. But what is RCV? It is a system of systems. It starts with a control vehicle, and we'll just keep it like that. 1 control vehicle in the back, 2 control stations with 4 operators who control 2 robots. And payloads. Minimum payload configuration. Crows J, tethered UAS. Are you going to sit there and we'll later, Ken, we can do better, we can do. This is a baseline configuration. This is the Lego building block of how the Army will roll out robotic combat vehicles. They will say, well, the RICTO's doing that. Yeah, I got it. RICTO's experimenting, bringing in more payloads. But we're setting the baseline configuration of how we will deliver capability in time and space. Still with me? No one's asleep yet. This is good. How are we? This is even more complicated. This is, don't pay attention to the chart, but I'll ask the question, do you understand how the Army delivers capability of a program in time? We like things very neat in the Army. We like a requirements document, says, I need a widget. The widget looks like this, and needs to be able to do these different things. And then we get it funded and resourced. And you say, I'm going to deliver, we'll say 2,000. 2,000 to be delivered in time and space. With RCV, we said, let's not do that. Just listen to what Army leaders say. I want to be adaptive. Because remember I said, an RCV is the base platform, the Lego building block for capability delivery. So we said, okay, well, let's design it around that. Mission set, basic, tethered UAS, Crows J, Overwatch. What can it accomplish? And then fixed sprint of time, which is really dependent on capability. So as new capability becomes available, or technology, we can plug it in. And that's what this strategy is here. As capability and technology is ready, we can plug it in. And we are not held to the traditional model of, I got a requirements document, and I can only deliver what my requirements document says. This is different. This is very, very different fundamentally than the way we do business. At the same time, it's all driven by software, where we are doing continuous improvements, continuous delivery of capability. One other takeaway on this, which is there's one little dot up there in 2028, and it says FUE. First unit equipped. You say, hey, you got to be able to faster. So within another month, we will announce the down select of a competition for the base platform. And after that, I will go into very, very deliberate testing, both from developmental and operator, to say, hey, does this do what we want? And if those blocks are checked, if it's reliable, if it's suitable, if it's all the other boxes that I've got to check, and if it's safe, then 2028 is where we're going to deliver. We are hyper-focused on that. Everything. And you think 3 years, well, it takes time to build these things. It takes time to test it. You just got to remember. So it'll come up again. Why 2028? Because to me, and then we'll connect it to where you guys are interested, autonomy. So we've had conversations. I've been in more conversations than I would like about autonomy. Because I bet every single one of us would put it in a different way. And what does it mean? It's an open question, right? What is it? It means something different to you, to you, to you. So we had a long conversation within the Army. And the Army's chief roboticist, Dr. Bob Sadowski, said, hey, Bob, you are the roboticist. You help us out. Because he could sit there and say, I could show you 10 different scales of 40 different organizations, but as a way for the Army to start talking with one voice. So Bob came up with, right? Because at the end of the day, I want the programs to collaborate. I want everything to be an automated effect, and I want the robot just to move wherever it is. Depending on the payload, the platform, and there's little things I can do. But today, block 0, right? First step, direct control. We call that teleop, right? But it's direct control. That's step 1. Payloads, manual effects, Crow's J, all right? The operator will control it and put it where it wants. And then the platform. Right? Now, we have systems in the Army, and we'll talk about a payload, right? Automated effects. I field an automated effects platform. It's challenging. That in a piece by itself. It is extremely challenging. It took significant resources, senior leader buy-in, and a whole lot of effort on our part to be able to deliver capability with automated effects. A standalone on a platform that already existed. But to deliver that as a full package, there are some challenges. And when we talk about it, and we talk about the kind of the general strategy that we're going to go after, think about it like a walk or a journey, and not just an end state. Like, boom, we're there, you're going to get everything you want. It's not. Because we've made investments through my office. Where is the current state of autonomy? And I love it. The vehicle's driving around here on the street, because it actually leads me to my next chart, which is, because we're in the Army, we like to get a visualizer, right? It's easier to visualize, right? Would the car that's driving down the street, would it do really well driving off-road? Probably not. Okay? And really, this is it's a very simplistic way as we start talking to senior leaders and then defining it, right? If I take the definitions of what is autonomy, how does it connect together, and then I put it over terrain. Because at the end of the day, the ground is hard. And I love my air brethren, right? UAVs, they fly through the air until they hit the ground. The ground is hard. And this is just, when you take these two concepts, right? Definitions of autonomy and then how we view terrain. And we start looking at that and saying, what can I do? What can I achieve? Because today, we have not seen one person who could do, or one vendor who could do everything perfect. But what we did see, there are some things we really like that they can do. There are pieces that will make a difference to the soldiers, as long as it meets all those other requirements they read out. So that leads you to, this is a little bit complicated, but how are we going to do it? Well, we started with an industry day, was it back in November? We started laying out, saying, hey, we went into detail. Like, you want to talk about, please don't ask me questions about ODDs, like in detail. I can give you the concept. The smart guy, I left him at home. He works for the CFT, right? But then, how do we apply what is possible today? And I bound it with the resources that I have. And that's really what you see is this notional concept. And I'll talk about timelines next. This is the steps we're taking, right? Did an industry day, we're going to come back, we'll do an RFI next, right? That's on the next chart. But it's what is possible. Because I have multiple competing interests out there. But Is it a really great closed solution? Is it a solution that it's open, that is able to reuse some of the Army or DoD investments? So all that is a value proposition for me and our team as we look at it, because if you can reuse, that's great. If you can't, that's great too, because at the end of the day, it's about performance and cost. And you say, well, 5 to 7 years. Yeah, because what did I say? I said, I want a field in 2028. That's 3 years in the future. And I want to have capability, the maximum ability for autonomy at that time. So it really is, because I'm 5 to 7 years, right? I got to down select a vendor or a stack. I got to integrate it. I got to get it through safety testing. And then I got to deliver. And so that that's capability. What I really foresee happening is the hardest part of that is that test, right? And there's a little box right there in the middle. It just says CIA. That's where we're making our investments now. Because at the end of the day, we talk about risk, and everybody's got risk differently. But for me, what I care about is medium risk, which means about 1 in a million. Demonstrate 1 in a million. Well, I can't pay for 1 in a million testing. What I can pay for is an automated environment where I start a SITL and then a HITL, right? I start running that autonomy stack in a digital environment. It's a government, and there's a reason why it's government. Because the government could see it, and my test community could see it, and we could start really focusing in on how does it work. So that when we deliver and then we move to hardware, do we start those little one-offs, right? 1 in a million. Well, it happens 3 times in a million. Okay. When it goes to hardware, what happens? All right. And when I go to field testing, what happens? Now that gives me edge cases. But what I foresee happening, or probably, is that when we roll it out, it'll be in pieces. Right? Certain aspect, like I said, there are certain things that it does now that we see that are really helpful, right? Waypoint navigation, leader follower. Simplest thing, right? Because one of the most boring things is, hey, you got to move to an attack point, right? Robots follow. Well, operator could probably be doing something else to that. Just follow the command vehicle, get to the attack point. That could be 2-3 hours. I've personally been in the attack, and we were just trying to get to our release point, and I watched the 113 in front of me, the driver fall asleep and just start drifting. I'm positive I could hear his TC yelling over, like, in the air, because he was drifting. It is the most boring part, right? Those are the things that it will make a difference in the soldier. Right? The soldier will benefit if we can accomplish these things as we roll out capability. Concept. Here's the timeline. I would expect right now about the first week of March. First week of March, we'll launch market research. And you're going to ask me, with who? Where's Warren? All right, NAMC. If you don't know what NAMC is, please go see Warren afterwards. It's an OTA that we use. It allows us to execute this. Real simple. So before we get into real questions, any questions? And as you look at it, you say, well, there's my information. But if you want to get to the source, software control, it's Travis. If it's a robot, Steve. It's real simple. So start with, I'm going to open up to questions. Do you understand where we're going? Do you understand how the Army is building? It's basically our building blocks to deliver capability. Because it's about taking that first step. Because it's always been on the future. I'm telling you, I'm on a glide path, deliver within less than 3 years. And from there, it's technology-driven, resources constrained, and integrating. So I'd love to open it up to questions. If you've got no questions, I could talk some more about whatever else you'd like to talk about.
Sir, Pat Acox, Forterra. Really appreciate the layout that you had there. I'm wondering from the government side, what do you see as key ingredients as you go from like block 0 to block 1, to keep from regressing and have to rebuild block 1 or block 0 when you do block 1, block 0, we do block 2, et cetera?
So, a couple things, and it's a great question, right? Based on technology today, as we look to different blocking strategies, it's about swap, size, weight, power. What I can't have to happen today is like, I got a great new counter UAS payload, right? If it exceeds the power of the robot in the near term, this first for 2 blocks or a few years, 5, 7 years, power's got to come with it. So as you're thinking about, hey, I can create the best payload ever to do a task. The question will be, and it's really for us, is do I need the power to come from the robot? How does it communicate, right? Because if it needs something that's not there, then we got a problem, right? Now I got an integration problem. But everything about the first steps is about setting the architecture and the framework to be the universal skateboard. Plug in, work, and then a bunch of network stuff. Does that answer your question, Pat?
It does. So when we say CIE, is going to be the foundation to keep from slipping back, go through the
Yeah, oh, absolutely. Yeah, and that's the connection, right? As we look to every new capability, and that could be our debugging, it could be fact of life things. I do more fact of life like changes, which is usually driven by obsolescence. Got to requalify, you pick the subsystem, a card. Okay, so how do we verify that that doesn't need to be good? So us doing it in the CIE environment to be able to flush it out quickly, so then that dramatically reduces my time and test on the backside. Because that will happen. I will deliver a robot, and I got my fingers crossed, but I'm hedging my probably is that every one of the subsystems will be obsolete at some manner. Because it's electric drives, it's compute, it's sensors. I mean, you guys are experts in this area, right? Because whatever sensor I pick today, there's going to be a better one, right? You got a better one, right? There's a better sensor, cheaper, smaller, faster. So how do I integrate that? And Pat, you hit it. It's the CIE environment. For us to be able to quickly look at that and say, do we have unintended consequences?
So, thank you. And it's a plug-and-play system that you're talking about. We're small business, and I'd like your perspective, or the Army's perspective, on proprietary versus open source. Because innovation costs money, providing a service costs money. To make the innovation requires proprietary income, not just providing a service. You have to make the profit to be able to bring the innovation. How is the Army looking at that desire for open source, which does not pay for the innovation? How do you make money on open source? I guess maybe that's the question.
No, that's a good question. So in this competition, we'll keep it in the software autonomy, or you want to talk about hardware? Because I can go in a lot of different ways. One is we care more today about how you get your money and how you develop your code, just so that we can make sure that it's traceable. With the understanding that, yes, it's the business relationship, right? Whether it's with the software vendors or hardware vendors, it just all sitting together. It makes it easier. I can point in that direction over there. It's a balancing act, because at the end of the day, it's not about the initial integration, it's about the long-term sustainment. Because, as we look to take a stack in, how much is it going to cost us to keep it in the field? And I think that's the ultimate balancing act we're going to have in there. Because I respect your investments, and then you need a return on investments. However, I work for the government, and we're not for profit, and I will beat you up like at nobody's business about what your profit margin is and not on your efforts, which is fine. But what I really care about is the sustainment over time, because I now have the responsibility to maintain the software forever. I used to be able to, I'd field it and they would go off to another organization. No, it's all about the program office. So that's the balancing act between if your software works great, but it costs me so much money, that's the trade-off that I will make there. And it's really about that long-term sustainment. And I understand that. So it's a balancing act. And that's really what it comes down to. When I go to hardware, it's the same. I ask for special purpose rights because I have to, what's going to happen? It's going to break. And how do I fix it? Am I only going back to the vendor? Or are you? Like, are you the only one? Well, sometimes, software is a little different, and the model will be different, but it's a short sprints of, okay, I'm willing to work with you, and I'm willing to pay your sustainment costs for a short period of time before I take a step back and recompete. Okay, sir? It's a challenge. It's a challenge. You want to talk hardware? I'll beat it every day of the week. I'll ask for special purpose rights because I want to fix it. I want to fix because it's going to break. And then I'm going to complain about it because how much is it going to cost? Because I've got competing statutory requirements where a certain percentage of the things, especially we're talking ACAT 1 world, I got to rebuild it in the depot. Well, depending on what it is, if it's wiring harnesses, whatever, it's totally reasonable. So I'm asking for special purpose rights and certain things like, hey, I want to be able to fix this. What's that long-term sustainment strategy? And that's what they talked about yesterday. Because if it can't be fixed and maintained for the long run, soldiers don't want it. It does them no good if it's broken in the motor pool. And the answer is, well, that's a 12-month lead time on that. So.
Hey, sir, Tim Bishop, Overland AI. Thank you for this. It's incredibly informative. One question I did have is on a previous slide, you kind of had 3 swim lanes of like mission control or command autonomy, platform, and payload. And I would love to get a little bit more information of how you think about the interplay between those. For example, I can imagine there's probably some core level of platform and payload autonomy you would need before you graduate into like the real mission control autonomy. And so not exact dates, but think about how do you think of the interplay and the progression of those in time and space?
So how do they play it? To me, it will be, it's all about the integration and how smooth the transition is. Because, and I think that's, one of the areas we looked at a lot right now is, at the end of the day, how quickly can an operator transition from, hey, I gave it an intent, just drive here, right? And then, oh, I need to take direct control because something's happened, and then back and forth. So to me, that's software people, that's challenging, right? Because now you have the control of the individual robot versus the stack, and how does it take control and give up control, and vice versa. It's like driving my wife's car where when it's in its automated driving and it wants to fight me. That will frustrate an operator, right? That fighting, like, hey, I'm trying to take control. No, I'm in charge. And then some of that is further compounded by latency, right? Because I'd love to think we got it perfect there and it's only acknowledged on there, but we're constrained to line of sight right now because I have that control. But as I move beyond that, latency is a problem.
Good morning. Thanks for that presentation. Eric Krotkov from Off-Road Autonomy. Where do legged robots fit? I saw some on your charts. HMIF armor doesn't seem the right home for them. And you didn't really talk in any of the charts about HMIF-I. So I guess my question is, where do legged robots fit in GVSC and the bigger HMIF enterprise?
So I would defer my question, that one, to the RICTO folks that are here. I know I've seen a couple of them, because especially when you talk about, and we'll just try to decompose that, right? So there is the ongoing HMIF armor and infantry integration efforts, which are being led by RICTO, right? Those are pushing the bounds of what is possible. Now, I am very much tied in with them, but RoboDogs is one of theirs, right? They're working on that because a lot of that's about integration and control. For me, it's a future capability that's why we're tied into, and how is it ultimately? How do you control it through the interfaces? But in the near term, it's a step back and watch. But I would recommend any of the RICTO guys, and I think they were here, talk to them about it.
Hi, Colonel Bernier. Thank you for your presentation. Jason Devitt from Compound I. Very interested in how these technologies, or what do you see the connection between these robotic technologies and perhaps manned vehicles? Like how many of these technologies will make it into manned vehicles for driver assistance, for APNT, for all of those features, and how do you coordinate that across the Army?
So I could talk about how we're doing it in GCS. I'm very close to my two brethren. One is the XM30 program and one is the M1E3, right? And both of those see exactly what you just said, some level of autonomy coming in there and being able to share. And right now the PEO GCS direction is, one is high level is once we start solving problems, we are not going to solve it 3 times. We want to solve it once. So high level, we see a library of capabilities starting to be consolidated. So autonomy is one of them. As we make investments and say, okay, here's an autonomy stack that the Army's willing to license for 3 to 5 years. It's going in the library. Because at the end of the day, fundamentally, an XM30 is a 2-man crew, 2-person crew, an operator, a driver, and a payload specialist who could be either one, which is very similar to RCV. So the high-level intent is start making longer strategic investments and being able to reuse. Okay, welcome.
Hi, thank you, Colonel. Aiden Spira, DroneX. How can we, a smaller business who may not have the whole platform to be able to develop the entire platform of the ground vehicles and drones, but instead want to work on payloads, actually get the information we need to design these payloads for these new systems that we are not like in contact for, like that you discussed designing today?
Yeah, so I would say if you're not connected to the different labs within the DevCom, so AAL is a great example, and then as it that traceability, because a lot of the fundamental, the 6.3, 6.4 work that's being done is being done at the labs. And then as we, as like RCV is now we're converging out of experimentation space and we're moving to integration. That's where we're, what is available? What capabilities can we be able to easily pull in? So that's the direction I would give you. Oh, absolutely. So to look at the different areas, because they're the ones that are continuing to make investments in that space for a small business to be able to, and they all of them have different OTAs and different methods. I'm sure someone else is a better expert at it than I. Okay, you're welcome.
So JD at IoTAI. The question is, yesterday you had maneuver support, and maneuver sustainment. What do you envision across those horizons of where this platform should be, could be, and then things you desire it to kind of experiment at?
So you're sitting 2 people away from a requirements guy, if you haven't met him. So when it comes to RCV requirements, he's actually way better because he's got a lot of demands on me, and a lot of them for us is rack and stacking priorities based on resources. So as we look across all of them, again, there's a lead sled dog who gets to choose those requirements. I'm not pointing fingers. I am, okay? But ultimately, that's what it comes down to, right? Capabilities. What is possible? What is in the realm of possible? Them understanding it and saying, hey, this is really important to me. I need it now. Okay. Of course, you got to remember now to me is 3 to 5 years, just because it's about the integration and getting it and delivering it, testing it, making sure it's safe. With risk, sometimes we can go faster. Good question, though.
Hi, good morning. Aaron Kane from BH Sensors. You've talked about the platforms and the down select. Can you talk a little bit about where sustainment, keeping the vehicle in the fight, comes in and how that's being integrated? I assume it's not after the platforms that then we suddenly figure out and talk about sustainment. So can you talk a little bit about where that fits in at this beginning stage?
So total life cycle management and responsibility does fall on my shoulders. But that's a back and forth conversation between us and the user community. Because at the end of the day, we don't want to grow new MOSs, right? So that's the balancing act that we're going through right now, because we're trying to develop a robot that's going to the forward line of, period, the forward line. We say troops, but they're ahead of the troops. So how do I sustain that? One of the key attributes in the RCV program was maintainability. But how that's maintained in the long term is important. Maintenance report strategy is something that we're working on, and then balancing that with the bigger community, because there is open acknowledgement that a Bradley mechanic and how we train them may not be the best fit for an RCV or an XM30, a system that's highly, highly dependent on the digital architecture. So.
Hey, it's a great presentation. Thank you. Lawrence from Code 19 Racing. I just was curious to see how you're thinking about simulation as you look on the 5-year horizon. And, you know, it's very important to test and simulation for systems. But then how are we able, like, is there going to be a way for us to bring our autonomy stacks into a simulator with, you know, other RCV or other vehicles and be able to sandbox and experiment, you know, with as part of, nested within everything that you're doing?
No. You hit it, that's long-term vision, right? Is step one is developing that long-term model and sim environment where we can then persistently update or pulse industry and say, hey, I really need, can someone do pick your function? And then the first step is deliver it to a model and sim environment where we can test it. So we can burn down all the risk and say, hey, like, because at some point I'll know exactly what robot I'll have. And so the architecture and stuff like that, and like how are you interfacing? How does it come in there? So that is one area we are making active investments in. A CIE environment, establishing the HITL and the SITL so that we can be able to accomplish that. And then persistently, so then the cold months of Michigan, instead of us going to the test range, we can be, you know, burn in electrons. That is 100% our plan. Hey, well, thank you so much. I really appreciate it. The contact information is there, and I just reinforce. You want to talk? You ask me a question, unless it's very general, I'm going to go to Travis or I'm going to go to Steve. I'm not saying I'm middle management. Sometimes I feel like middle management, right? They're the experts. Now, they don't respond, just you include me, and we will do our best. There are lots of you and few of us. I thank you for the opportunity. I thank you for what you could do for the Army, because at the end of the day, the one thing I care about is delivering capability to soldiers and making their lives better. That's 100% of my focus. Deliver RCV in 2028. Deliver Booker later this summer. Deliver SMET Inc. 2 probably in 2028. So with that, thank you so much. I appreciate it. I hope you enjoy the rest of your conference.
All right, before we head to our break, if there's a David Elliott, if you go see the front desk, we'd appreciate it. David Elliott, if you go see the front desk, we'd appreciate it. Where's our Rictoa folks? We got hands up. Anybody from Rictoa sitting in the room? They're hiding. They're hiding. We'll find them. That way you can talk to them. Rictoa, off-road autonomy is looking for you. Is that right? So let's go try to help them out. Hey, we're going to break here. We'll be back at 10:15 with our next two panels.
Red is off.
We can start making our way back to our seats. We're going to kick it off in about a minute. Let's start making our way to our seats, and then we're going to get our first panel this morning rolling. All right, folks, let's go to our seats. Let's get ready for this next panel. Our first panel this morning will be Closing the Loop, Advanced Autonomy. Advanced Autonomy, this panel will talk about advanced autonomy, how they think it's going to reshape, redefine military operations. They're going to talk about the hardware, the AI stacks, and how it is working in the business realm and how it can work through military operations. And so, moderating this panel this morning will be Mr. Ray Compton, retired colonel with the Army Science Board. We have Luis Cintes from the University of Texas. We have product lead for Project Linchpin, Bharat Patel with PEO IEWS. And Jordan Coleman from Kodiak AI. Please give our panel a round of applause.
Well, let's say it's good morning, good afternoon, depending what time zone for it. Hey, I want to kind of choose something a little bit different. We talked about it in a group, and I've had a lot of time with Army Futures Command and my Army Science Board role. So, you know, kind of when I look over my 30-year experience across the ecosystem, I kind of wanted to set the stage a little bit. And we kind of gotten this to our speakers over the 2 days. And, you know, when we consider autonomy and autonomous systems of the future, this complex challenge is not just an I issue, but we truly have got a we opportunity. The opportunity is not merely a technical challenge, but a system issue that requires a collective group and a collective effort. With this audience online, we've got to remember that we've got such key stakeholders here. We have the users. We have the industry partners, not just the industry partners, but ranging from the venture capital to a lot that we heard today from the non-traditional players. Academia, TRADOC, who's driving our new concepts, Army Futures Command and the cross-functional teams developing requirements, and also, just so we had the PM, the acquisition community. But I want to put a little spin on that. This is not just the PEOs, your PMs, and your traditional contracts. But when we talk about this environment, this is also the partnerships with our labs and centers that are leveraging their SIBRs, there's broad area announcements, and there's other transaction authorities to identify and integrating technology. The vast ecosystem, the we, is essentially particular in the role of autonomy to drive innovation and to deliver integrated and supportable capability for our warfighters. I would like to take 2 minutes, and again, as I introduce Luis Cintes, Professor of Aerospace Engineering, allow him for 2 minutes to introduce yourself, sir.
Well, thank you so much, and first of all, thank you to the whole DoD, the community and the S&T community within DoD for really being wonderful at providing the resources that we have in great universities like the University of Texas at Austin. Our research and our influence on AI and robotics will not be at the same stage that we are today. No way will be the same stage that we are thanks to this funding. I have a 15-career faculty here at the University of Texas. I have a PhD from Stanford University in electrical engineering, and I'm the founder of a company called Autonomy, who builds humanoid robotics. I've spent my career, one of these unique cases of building an entire career on humanoid robotics. As we say, before it was cool, Now, Autonomy is a company that it became a unicorn already a few months ago. A lot of it benefiting from DoD funding, and now being with some of the big tech, in particular DeepMind, being behind, because hardware and advanced reasoning, advanced inference, they have to go hand in hand. And I guess I want to make it brief. So thank you all for being here.
And then Bharat Patel, I don't believe it. I think sometimes he's got the hardest job right now in the Army as project lead of PEO, IEWS. And if we all heard for autonomy and everything, Project Linchpin.
Hi, folks. My name's, again, Bharat Patel. I've over 15 years in the acquisition community. I born in Chicago, grew up outside New York City. I walk out of my house to the left side, I saw Twin Towers every day of my life. And one day I was in college and I saw only one tower. And then the other tower went down. After that, I joined the Navy, sailed around the world for a little bit, got out. I joined the Army as a MITRE employee and then a civilian eventually, but that kind of drove my passion to do something. And I've seen good, bad, ugly parts of the acquisition world. I've been in front of studies, pilots, and prototyping my whole career. So shaping mostly on the intelligence side, shaping all signals intelligence from ground intelligence, all programs within our intelligence, electronic warfare, and sensors portfolio. Had the opportunity to really change a lot of things. I pitched an idea. I pitched an idea of Project Linchpin, which was essentially how to effectively and efficiently go after AI. Just an idea. It turned out to be the Army's strategy to deliver AI to the programs. From concept to program, less than 2 years. Some folks think the acquisition community is slow, and I agree. But this is turning out to be one of the pivotal points where we are. I wake up every day trying to figure out how to win. I try not to go to sleep, because literally this is the pivotal point in our nation and our programs to get this right.
Now, as we go from government to industry, Mr. Jordan Coleman, Chief Legal and Policy. I never thought I'd have a lawyer and an industry partner on the panel at the same time from Kodiak Robotics.
Well, listen, thanks y'all for having me. Firstly, hopefully I sound nothing like a lawyer, but that's neither here nor there. Jordan Coleman, Chief Legal and Policy Officer at Kodiak. Kodiak is an autonomous vehicle company based in Silicon Valley with operations offices in Dallas, Texas. Kodiak was founded by one of the founding members of the Google self-driving team. I think importantly, and I think it's important to say this in this room, that program, which we now see driving around the roads that we all live on, was born out of the DARPA Urban Challenges, right? So that is really the birthplace of where the modern ground autonomy effort started, was with this community. Kodiak was originally formed with the focus of bringing ground autonomy to the over-the-road trucking space, right? Over-the-road trucking is the lifeblood of the American economy. Everything in this room and everything in all of our homes has been on at least one truck and many more. And it's a really hard job, and there's not enough people who are willing to do it. The average age of an over-the-road truck driver is 55. And so we said, hey, what a great way to bring technology to bear in a way that'll impact everyone's communities, driving down the price of goods, making roads safer, helping improve the quality of truck drivers' lives. That said, we've really always been a mission-driven company. We believe this technology can help save lives on American roadways. And as we started to think, well, what are other applications to provide this? I mean, if we had a moral imperative to help save lives on American roadways, that's all the more so for American servicemen and women. And so we really became interested and excited about the idea of bringing our technology to bear in the national defense space. And so started, as many startups will do, with a couple of SBIR awards with our friends at Dover Air Force Base, automating the flight line of the future. But very excitingly, 3 years ago, we were, through our friends at DIU, were introduced to the opportunity with the robotic combat vehicle program that Colonel Bernier just talked about. We submitted as a non-traditional defense contractor and a dual-use technology company and said, we really think this existing great technology stack that we built with funding from our friends in the venture community and otherwise can really be brought to bear specifically on this problem. And we're very proud of the work we've done over the last 2.5 years with our friends in the Army, showcasing at Fort Cavazos last summer, showcasing up in Grayling, which was particularly exciting as we'd never seen snow before. And I don't mean we'd never done a demo in snow before. Originally, that second demo was going to be in Texas as well, and when they told us it was up in Upper Michigan, we said, there's one small difference between Texas in November and Michigan in December, and it was snow. Pretty cool stuff that our team did. They literally took existing forested logs from our drives in California, style transferred snow onto them using generative AI, and trained our perception system to be able to make determinations as to drivable surfaces. So when we got up there, we'd never driven. The day before, we were going to be in Grayling. We did some work around some of the local secondary roads, and we're blown away by how well it works. So again, I think just showing you how robust this technology and how generalized this technology has become over the last couple of years. Maybe lastly, and I think this goes to that kind of full dual-use journey, right? The idea is let's take this great commercial tech, let's apply it to defense so that we can get all those learnings, all that data, all that value over to the defense community. Well, it really is a circle because after seeing what we've done in over the road and after seeing what we've done in defense, we got a phone call from a company called Atlas Energy Solutions, a local company to Austin, and they said, hey, we work out in the oil fields in the Permian Basin in West Texas and eastern New Mexico. We've seen what you do. You think you can handle our rugged environment? We said, heck yeah, let's see if we can try. So we went out there on December 26th of 2023, engaged the system for the first time on being there. And then by the spring, we're starting to do drive route deliveries of hydrofracking sand for them. And most excitingly, in December of this year, delivered the first two, as far as we're aware, third-party owned autonomous vehicles. They're owned by the customer, run using our technology, and being driven 24/7 every single day. And anybody who knows the Permian knows pretty harsh conditions out there. And so, again, this is where all those learnings, everything that we've built and everything we're showcasing out there, we can port right back over to our customer in the Army and provide immediate value.
So having a little fun here, I'm going to take a kind of a line from Colonel Kim Vernier. So I'm going to take it and let our panel kind of go autonomy. So I hope I'm not going to have to be that shoulder and grab the steering wheel and put us back on the path. But let's start off with today. So today, autonomy is often viewed as an object, such as a humanoid, which we talked about, a small vehicle or a drone. Looking ahead, how emergent technology like new hardware and AI drive autonomy, and how should we redefine what constitutes as an autonomous object in the future? Academia.
Yeah, so I think obviously we've been very sort of asset centric, and sectors of the Department of Defense are focusing more on what I call institutional AI, in the sense that we need to transcend the local team, the local setup, and having levels of reasoning and understanding at the entire organization level. This is important, and it has the dual use, the civilian and the military use, in the sense that in the production of humanoids, we have very high expectations, not only on the number of chores and how they can contribute to logistics and lean manufacturing, but how can they be deployed at large. And then the expectation is that when a teammate, a robotic teammate comes into the team, it sort of boards itself, right? Whether it's an operating base somewhere, or a military team, a company, any unit, or it's a company operating in a certain environment, the robot needs to start kind of learning and being inquisitive about what the ranks are, who knows what information, and start kind of scrubbing this information and then finding itself useful within the organization. Only then this asset becomes sort of an augmentation of the capabilities. We already have the augmentation of 24/7 operations, the ruggedness, the ability of going inside, with the Marines, with the troops inside a contested environment. But now we need this institutional sort of reasoning level that it knows where to fetch the information, how to perform a repair, how to perform maintenance, how to cater with the systems that it needs to use for deployment, and it does all in comprehension of the whole unit. So I call this institutional AI beyond the system itself.
And especially right now from the government, especially from you, especially in your views on linchpin. You know what I mean? When we're looking at this, it's truly going to drive, how do we describe autonomy? So I'd love to hear your views.
You're going to have to bear with me. I warn them. I warn them in the beginning. You're going to have to keep me on track. I have a lot of ping pongs in my head. All right. So I'm going to start with I love movies. One of my favorite movies is Idiocracy. So in the future, I could see humans dying because they're drinking Gatorade and can't figure out why they're dying from dehydration. Watch the movie. So what I'm saying is, AI will one day tell you what to do, right? It's starting to tell you how to think. You're starting to see it from basic things like your watch saying, hey, get up. It's planning your schedules. You're saying, hey, what should I eat for dinner? You're starting to see all of that, right? One day, you will see that in the future, but I'm excited to see the technology boom in industry. I've seen Tesla and all these new autonomy companies coming out. There's a lot going on. You're going to see a world where AI is going to supplement a soldier, supplement a commander, supplement even an acquisition professional with their daily life, supplement a contract professional with their daily life. So the industry is on the right path. Now on the DoD side, government side, it's hard to implement this because we're still trying to figure out how do we trust the recommendations coming out of things that are undeterministic? How do we trust the things that are possibly not tested to its full potential like we used to do back when we wanted to shoot a cannon over, because that's much easier to test. But I see a lot of potential. We're starting to figure out a lot of these basic concepts. One of our key areas that we need to focus on is providing you and industry the appropriate use cases. So take Tesla, for example. Or Waymo or anyone. They're driving down roads, but are they driving down roads with smoke, with blasts, with people with weapons? What do you do in those scenarios when a vehicle is driving and you have these scenarios come up? What does the vehicle do? How does it react? Those are things that we need to figure out and test and build towards. Who has that data? Ukraine right now is probably the most relevant place to get that type of data. And if you think about it, what are the sensors on those vehicles? Are they relevant to the sensors that industry is working on? Your 4K video is different than the sensor that's actually on the platform of a tank. So if you're building autonomy on a 4K sensor, it doesn't automatically apply to the sensor that's on the vehicle. These are basic things that we're trying to work through. And I think we're going to get there.
So Jacob, on the same question, that like what we talked about before is on the same thing as we look at autonomy in the future. You know, how do we look at possibly autonomy from the industry aspect of being that app or possibly being a module versus, like we talked about, not an actual thing with wheels on it?
Yeah, no, I think it's a super important point, and I think it ties back to the last question. So, you know, I think one of the most, in our view, granted we're biased, one of the most important things that was done on the robotic combat vehicle program was leveraging the software acquisition pathways, right? Understanding that traditional primes and the vehicle manufacturers are amazing at building robust, capable, durable vehicles, but that the kind of cutting edge AI systems that are going to drive these vehicles, right, that are going to serve as these virtual drivers, were being developed in a different part of the world, and frankly, software-centric companies, right? Anybody who works in autonomous vehicles, of course, we're going to have to touch and handle hardware. We do it every single day. But in the end, we're primarily focused on the software. And this is where, right, we talked about the three verticals that Kodiak is playing in over-the-road, industrial, and defense. If we were trying to build three distinct products and three distinct code bases, we would be wildly inefficient, we'd be wildly unsuccessful, and we wouldn't get the learnings from a cross-platform perspective. So we are building a singular product that happens to drive a variety of different vehicle types, right? We've integrated into multiple different Class 8 chassis, both kind of typical over-the-road trucks as well as vocational, heavy-duty reinforced chassis for our industrial work. As a down select to something a little more capable of some of the more broad ODDs that Colonel Bernier talked about earlier, they said, hey, a Class 8 red truck's great, but that's not going to work in through the field. So first we worked on a Ford F-150, not a military vehicle, but obviously something capable of a little bit more off-roading. But again, and we kind of got the question, F-150 is great, that's still a passenger vehicle. And we work with our good friends at Textron Systems to integrate our system into their M3 Ripsaw, showcasing what's possible in a treaded vehicle. But importantly, it's the same AI driver across these things. Now, that's not to say there aren't knobs that you can turn. Needless to say, when you're driving through a field and in a treaded vehicle, you might want to say, hey, we can run over more things, right? To your point, in these more dynamic environments, we may need a more aggressive action, right? Like, needless to say, from an over-the-road perspective, if a person steps in front of your vehicle, you need to stop. That may not be the case in theater. And so, of course, we're cognizant of those things, but we need to build this software that stands on its own. And again, importantly, the number of vehicle types that proliferate across the Army, but also the Department of Defense as a whole, is enormous. And we need to be able to build a capable driver to handle any and all vehicle type. And so that's really what we are focused on as a company, and where we think we can deliver value to the Army customer, right? They're not saying, hey, yes, they're saying, hey, automate the RCV right now, but what they're looking for is a driver that can work across vehicle platforms, and we're excited to be working towards delivering it.
Not being funny when we talk about the autonomous vehicle in combat, it's starting to have flashbacks of Mario Kart. And so I wanted to pull on some of the threads, and y'all commented. And so, as we look at autonomous technology rapidly transitioning from commercial applications, to a battlefield capability, how do we address the non-technical? We always call the non-M portion of it. We've been hearing about it, such as training, trust, operational concepts, force structures, and policy. And funny thing is, I want to start actually on your side of the house and kind of that legal, because it's got to be a battle. I mean, even with the industry, you're battling those two things, on the industry side, especially in that area.
No, without a doubt. Listen, I think actually where oddly I'll start is not on the legal side, but it's actually on public trust. And I think that extends into the defense context in terms of trust of the operators, trust of the warfighter. In the end, there needs to be belief in the fundamental safety and capability of these vehicles. Now, this is one of the ways where we're lucky compared to Waymo. Waymo, you need to not only be able to safely get from point A to point B, but somebody's got to enjoy the ride while they're doing it, or else they're not going to do it. Needless to say, in the over-the-road trucking side, a 53-foot dry van filled with, Coca-Cola products, they're not too worried about if it was a little bit of a bumpy drive. But in the end, the public writ large needs to trust this technology for it to proliferate. And the same is true with the warfighter. And so it is incumbent on us as Kodiak to not only build a capable system, but to build that trust, be it, working directly with COCOM so we can make sure that these vehicles are in hand, whether it's showing up to a wide range of demo and other opportunities. So again, people can see and understand what the capabilities are. And from there, I think then the call can come from within the house, right? I think in the end, if it's just industry saying, hey, this technology is there, it's ready, it's driverless today, that's not enough to make the adoption. But I think if the warfighter is saying, I want this in hand, I think if the public is saying, I want this technology, I think it is the sort of push necessary to make this happen, right? I think Bharat noted it, right? The acquisition community is amazingly capable, but sometimes inflexible or resistant to change. And I think if we can convince the user writ large of its importance, I think it's going to go a long way. I will also say that the policy side is really important here, right? We talked about it. If not for the creation of software acquisition pathways, Kodiak would not be working in defense, period, full stop. And I think we need to continue to think about that, right? Whether it's concepts like Replicator, whether it's concepts of what I've heard rumored of things being, moving in a similar direction, flexible acquisition approaches, thinking about the way that you purchase and sustain modern software products, et cetera. I think those are really important so that the tools are in the hand of Bharat and the acquisition community in order to field this evolving and iterative technology.
And Bharat, kind of want to look at it from your side. When we look at Project Linchpin, we kind of talk about the non-technical. We had the conversation about data. How do you see that we're going to have to change to have the autonomy, infrastructure, those things? We kind of forget about that support that's necessary. Like you said, to process all that data, for the future autonomy.
So technology is out there. Technology. Look at this room. Look at I was in San Francisco last week. There's so much technology everywhere. The challenge for us is how do we adopt and integrate that technology? And the biggest hurdle for us is moving it. We call it the valley of death, but I don't necessarily subscribe that there is a valley of death. I call it piss poor planning. It's being able to effectively understand how the tech is migrating, but then also convincing our user base as well as our requirements community. So that's two different things, believe it or not. You have a user that uses the weapon system or business system, and then there's a requirements community that documents what's actually needed. That process still, it needs to speed up. It needs to speed up. In order for it to speed up, they need information. What is the state of the art? How can my force structure change? How should my concepts of operations update based on the technology? We call that science and technology. Science and technology should be informing these kind of concepts, but then we immediately grab towards the tech. On the PM side, the tech is easy. We need help with how should we employ this technology. So oftentimes there's a mismatch between, hey, the PM's not going fast enough, or the whole process is taking too long. On our side, we don't understand how to deliver this to the user through the traditional requirements process. So for us, the .mlpf process, the doctrine, how is the user going to be trained to use this system? How is the organization going to change? What are the policies that need to be in place? These are the things that are actually the biggest challenges in adopting technologies. If we can figure that part out, 100% will be much faster. On the acquisition side, we 100% need to go faster. We're adopting software pathways where we can, where there's a bunch of new policies in our avenue. We need infrastructure in a place to hold and secure our data that allows industry to come in and we could test your capabilities. So what that requires is a significant investment on our part, which doesn't always happen, because the easy button is, hey, I'm going to do a contract and I'm going to select one or two companies, and then they're going to build my system. But how do you create an ecosystem that allows us to continue to check and integrate new tech, but play around with it with relevant data, so then we can figure out how to integrate it and push it out to the warfighter? Again, those are some things that are always and consistently on my mind. And the core functions of Project Lynchpin is setting up what I always call the boring side of AI, the infrastructure, the standards, the process, the governance. And that'll allow us to tap into the ecosystem across the United States, bring in companies, and then push them out to the warfighter.
That's great. I kind of want to look at the academia. I think sometimes we forget that in some areas, especially some of our academic institutions, they're almost a business of themselves. They've got both sides of the house, the business side and then saying it. So from your approach, how do you see academia and being in that non-technical, not just supporting like your SIBRs and stuff, but also how do you see the changes they're going to have to bring the next generation to be able to come to the workforce to address these issues?
Well, I think investment is key. S&T, all the way from foundations, tier levels 1 and 2, but then there's a lot of appetite to move beyond tier levels, all the way to tier level 6. Mm-hmm. And then we do have myself. I have a contract with the Space Force, and we're going all the way to tier level 6, right? We have contracts with Axiom, building the next space station, and also we're going to those levels. So kind of exercising those tests of how far we can go. I wish to see from the DoD a more comprehensive effort of building institutes of AI within academia. We've seen that in NSF, and that results there's 25 million several institutes of AI across the country happening. Those are sufficient monies to actually invent the new next generation transformative algorithms and some of the architectures, some of the mixture of experts that we're seeing now making a huge impact. Memory and flops are the two parameters that define our AI capabilities. I was just having thoughts when we define it. We need to be able to increase that as much as possible. But before that, we have to have the ability of scaling and being as efficient as possible. DoD efforts on creating institutes within academia in partnership with startups and large companies is fundamental to creating these GPU clusters and these architectures for training and inference that we need, that the DoD needs. And to that respect, I also want to bring that the DoD, from my perspective, should be bidding for having some of the biggest GPU clusters in the world. We're talking about H100s, H20s, on the 100,000 orders, powered by the whole pipeline of by gigawatts, maybe even all the way from 1 to 10 gigawatts. If we want to compete with China in particular, right, we're seeing those scales happening very quickly. I think the tariffs, the export controls are making an effect, but sooner or later they're going to get there, right? So that's going to happen at the hard tech, big tech. But I would like to see that in the DoD. I would like to see the DoD having their own GPU clusters and teaming up with academia in getting the very best, the nascent algorithms that are coming up with these partnerships.
So I want to go back to industry and look at this question, the panel, but I want to pull from you, because we've talked about software pathways, we've talked about processes and stuff like that. And one of the things is coming from industry, and you also see it from the commercial world. They're like, hey, commercial world is anticipating faster. So how do you think that, from each one of your perspectives, that we may need to change something in our ecosystem that we can anticipate and adapt to the rapid technology to push those capabilities forward? So start with industry.
Gosh, great question. I think it's, I know exactly what I'd speak to, which is data, right? Which I think is something that's talked about a lot. And I think there's kind of always the question of kind of data ownership, data fidelity, where does the data come from? And certainly not to downplay that. But I also think this is a place where dual use really can bring a heavy hammer and provide a lot of value. When thinking about kind of total miles kind of driven in ground autonomy for defense applications, I've heard a number of figures thrown around, but all of them in the tens of thousands, potentially hundreds of thousands of miles, and that's great and that's good data. Kodiak alone has driven, we're fast approaching 4 million miles on the commercial side of the coin. And that has allowed us to capture an enormous amount of data to then be able to train our AI systems to be advanced. And I talked about it earlier, kind of the cross-functional and the singular product and our ability to take the learnings from each and port them over. Sometimes we get the question of, well, we need to make sure that it's only our data, that it's trained in, that it's separated, it's trained in a proprietary way, and then that's what you deliver to us. From our perspective, that's the wrong way to think about it. That we need the most important thing. It's not to have the largest data set, right? That's not it. It's to have the most diverse data set possible, right? To the point that was made earlier, which is we're trying to train these AI systems to do things they haven't done before. Well, the only way to do that, you got to feed the beast. You need a diverse data set in order to do it. We often get, talk about interventions per mile, which is a number that people love to throw around. And we always say that's the wrong way to think about it. You actually want interventions, because if you have interventions, it means you are putting your robot into new and different scenarios. You're telling your safety driver, hey, if you're not feeling comfortable, intervene, because we'll take it into simulation and we'll actually see if there was an issue. That's every one of those interventions is an opportunity to train that robot for the engineers to say, hey, was this right? Could we tweak something, et cetera? And you could have amazing statistics if you took an autonomous vehicle out to the middle of nowhere on a highway and I-10, a dead stretch where nobody is, and drive it back and forth and back and forth and back and forth. Your numbers would look great, and you'd have a system that wasn't capable of anything. And so, from my perspective, we all need to work together to understand how to capture the right data, but to rely on an extremely broad and diverse set of data, because that's going to make the most capable robot.
And Brian, I know, I've seen you, at events and stuff like that. You've been traveling, especially with the latest RFIs coming on Project Linchpin. I mean, what's your perspective, how we've got to change the ecosystem? I mean, you've got one of those forthcoming areas with AI and machine learning that's going to be a key part of autonomy. But how do you think changes on the government side, on the ecosystem?
One of the biggest things, going back to data. So I'll start with algorithmic warfare cross-functional team stood up in 2016, 2017. And that was codenamed Project Maven. So Project Maven stood up, and it was one of the DoD's biggest AI pathfinders to accelerate AI adoption. And it was essentially Silicon Valley companies coming in to enhance the capabilities of the warfighter. The biggest challenge of that entire process was, how do I get relevant data to those companies? So with that, we need a significant amount, going back to your GPU cluster, we need infrastructure investments. We do have the DoD high performance computing centers across different laboratories. Those are clusters. A lot of them were CPU based. Now they're starting to get, some of them are heavy on GPUs, but we need more of those. We need significant investments there, but those are also not necessarily cloud-based data environments, they're clusters. So if you plug into them, because I've used them, you plug into them, it's not a environment where you could have lots of companies come in or partners come in to leverage those clusters, because they're not managed that way. Now, in most cases, you could go to the cloud. Which cloud are you going to go to? Right now, AWS is the winner of them all. Google's now in the game. Microsoft's in the game. Oracle's in the game. There's more in the game. And they all have tools. They all have tools and technologies. Do you want to use their tools and technologies? I guarantee you, you have better tools and technologies. So I talk about table stakes all the time. We can today do AI. Put it somewhere and go after it. But that will lock us into a solution. One solution, two solutions, three solutions. It will not tap into the ecosystem that we're trying to create. Table stakes. So what we're trying to do is go after the standards, go after the process and the governance that allows us to create more of a competitive environment. I'm going to have all those partners in my office in the next month at the lower levels to go, hey, listen, all of you guys are in the game, but there's more than you. How am I going to leverage your computing environments to create an actual environment, not an MLOps pipeline, but an environment that allows me to bring in whatever I want to, give them access to my data, and then test out their capabilities. So I'm literally going to force them to start thinking about creating more of a competitive environment for the United States. Table stakes. The other part is MLOps pipelines. You could buy one right now, more than one. But again, you're going to be locked into a solution. So I've partnered with Red Hat and the Army Research Lab to create an open source project to get after an MLOps API that the industry community can adopt and implement, that allows us to break up the pipeline to bring in different tools. So go to GitHub, look at the MLOps API, provide some feedback. It's on, I would consider it 0.1 version. It needs help. 1.0 will come out in about April. That will allow us to figure out how to integrate more tech into the whole process.
So in the academia, you pulled the thread about TRLs, and I think some people just don't understand sometimes. Academia is just not academia. The partnerships are across the academia. The UARCs, the University Affiliate Research Centers, the Center of Excellence that we have all the way from DoD on. How do you see that engine to help, or what changes to kind of help the government to rapidly bring in technology? Sometimes at that forefront that we don't even realize in those research areas.
But I think you need to find First of all, every faculty receiving DoD funding, they should be aware that they're getting DoD funding and recognize that and honor that. And that's something that I see a little bit less happening than it should, but I think it can be leveraged with the DoD, making sure that it goes that way. The second is that we need to find partners in the Army, and ARL is definitely a fantastic organization. I've had money from them, I work with them, but we are perhaps lacking a little bit of experts that can scale. So scaling, I think, is the problem. So there's a lot of creativity happen in both sides. We're operating similarly, and then what is the scaling at all levels? First of all, the infrastructure. What is the Army infrastructure that allows us to scale, and where are the experts that can take this kind of multimodal data from all of these companies, because one company is going to make it only, right? Apply all the generative methods, apply all of these scalable strategies, because at the end, again, memory, flops, tokenization, the number of, the size of the matrices, and we are, going to the 1 million to 1 billion tokens. How is it going to happen? I wish it would happen within the DoD. So if you give us the means of a scaling organization without the DoD, magic is going to happen with custom models. They're trained for they're trained on real cases, on doctrine, on evolving doctrine, on UAS systems that are specific for our military and our scenarios, theaters that we are facing. So we need that. Please approve the money.
Can I jump on that one, please? So scaling, so spot on. So on our side, civilians and military folks that are in the acquisition process, there's not enough of us to be able to effectively communicate technology to you. So digital literacy is still a growing thing within the DoD. So we're starting to move forward for software. People are starting to understand software. But now AI is completely different. You can't just think that I know software and now I know how to do AI, because we barely understand how to test software. We barely now understand how to cost for software. AI is completely different. You talk about tokenization, right? How do you cost for something that may or may not be deterministic or undeterministic? It may work, it may not. It's very, very challenging on our side. So in our process, we're pulling the best and brightest across the Army to help build my office. But most of my funding is going towards industry. We want industry to help us solve problems. We want industry to be in my office, to help us with the standards, to help us with the technical approaches.
Benchmarks. I think benchmarks also.
Yeah.
If the DoD says, we have to hit the billion token kind of threshold, right? And in that you can process, it's not one book, right? It's an entire, operation of an ongoing conflict being fed now to an inference model that can reason in real time, right? If we have these benchmarks, if you help us to have these benchmarks or have experts to design these benchmarks, then we can fight with a timeline against them and we can achieve them, right? That's huge.
Yeah. Exactly. That's why we need you guys in the office together.
Yeah.
Badges down.
It goes
Let's
back to
solve
the
problems.
ecosystem collaboration
Yeah.
we talked about across that whole spectrum.
Yeah.
And stuff like that. So, in our short time, and I'm going to try to keep it short on the panel and the answers on it, it's kind of like you're hearing today, HMI and autonomy, they can't be separated. You're going to have to, if you do autonomy, you're going to have to do the human-machine interface. And we kind of talked about it in today's view, we kind of look at it as a dog, a robot, on there. How do you look at in the future that we're going to have to look at HMI and autonomy, and it's not like bringing a soldier into a unit? So I want to start from the government's perspective on that, and especially with Lynchman. I mean, you're looking at HMI. Just how do we handle the AI portion of integrating the two grid?
I will attempt to keep it short. It's really informing our requirements process and our user base of the capabilities and limitations of AI, what it can and cannot do, what it should be used for and what it shouldn't be used for. So staying engaged with industry and informing our .MLPF process is going to be one of the most important parts, because we want to make sure that when we field and implement some of this, we understand the risk-based approaches and the risk models. That just means, does the autonomy shoot? Does the autonomy actually make a recommendation for something that either, I don't know, I need more beans and bullets, or do I trigger a call for fires? These are things that we need to figure out and wrap risk approaches around it, inform our commanders to get after it. So the tech is there, but our concepts are still kind of lagging behind.
And I want to do the industry. I want to bring back to what Colonel Bernier said, talked about soldier has in the steering wheel, or as he says, has his wife's car and I'm fighting against it. You know what I mean? How does the industry look at it to find that balance of autonomy and HMI as you're trying to bring, that enabling capability to the warfighter? It's kind of an interesting way of delivering a product.
Yeah, I think this is an interesting thing about the nature of autonomous vehicles, though. They start with a human in the loop by their definition, right? You don't start by having nobody in the cab and sending it on down the road. We have an amazing group of what we call safety drivers, right? These are, for the most part, entirely long tenured CDL holding truck drivers who have a great amount of experience, who serve as that person who's there to take over as the robot's maturing, right? I mean, I have 3 young kids. I think about it in a lot of the same ways, right? You start with infant care and you're changing 10 diapers a day. You get to the point where you can send them off to school on their own, but they still need a lot of help doing homework and going to bed. Eventually, they turn into teenagers and stop talking to you, and then eventually they can leave and handle life on their own. And I don't think that's that different, frankly, with a robot. And so we've had to work through those stages to get to the point where we are now with no driver in the cab out in West Texas. And so understanding the ways that the robot and human interact are something that we've done for the last 7 years. And to your point, we built a wide variety of mechanisms that are intuitive. And that's the real critical thing, is you have to build intuitive mechanisms into the system. It shouldn't be the human having to figure out how to integrate, how to, disengage or engage or otherwise the robot. It should be off the cuff. It should be what they would naturally do. And that's what we've had to build. And you want them super lightweight. The last thing that you want is somebody sitting there staring at a screen saying, what does that say? I mean, our interface is quite literally a light bar that's green if it's engaged, and orange if it's in fallback, and blue if it's ready to be engaged, and some very simple verbal cues. Because what we don't want to is increase the cognitive load. And that's for a truck driver on, I-35 right now, let alone the last thing we want to do is increase the cognitive load on the soldier. And so I think that's a huge part of it. The other thing that I think, and this somewhat goes more to the question that you asked Bharat, which is it needs to be a conversation, and it needs to be iterative. It can't just be the government saying, this is how it should work. It can't be just the industry saying, this is how it works. We have to continue that conversation on a continuous cadence so that we inform these decisions together and end up at the right result. Because I think the worst thing we can do is dictate from either side of the aisle, this is how it needs to work.
So before we go to Q&A, I want to do something a little bit on the speed round. All right, 60 seconds or less. But from each side of your coffee cup, you've got a moment on stage. What do you think that 60-second soundbite should be for timing in the future? Academia.
I think I already insisted multiple times, invest on infrastructure, poach industry leaders that know how to deploy at the scale, and the rest will follow.
Right. Ping pong, man. You got to you got the good ping pongs going here.
Demand more from us. Continue to engage. It's a contact sport. I always talk about it. Acquisition is a contact sport. You're going to find folks that are on our side that are willing to collaborate, and then there's folks that aren't, right? You're just going to have to work through it. We really need your help. We need your help. We need to figure out how to solve the hardest problems. And we can't do it without industry. If our doors are closed, you have to break them down. You have to figure out how to get around them. Because sometimes that's what we do, because we're terrible. We just don't, sometimes we're humans, and we don't want to talk to people. But there are folks that do want to talk and integrate technology and figure out how to solve problems. You got to find those. Far and few between, but I will help. I will help anyone that's willing to help the DoD and the Army. All I do is think about winning. I told you that. So if you guys want to help and get into the process, I'll figure out how to help.
A 60 seconds industry. What's
I'm going
your
to do
soundbite?
two 30-second sound bites. One, the future is here. So forever it was like, yeah, AVs are great, but they're not here yet. Waymos are driving around the streets right now. They're driving around San Francisco right now. Our trucks are driving around in the Permian Basin. Nobody in the cab. This is no longer we promise it's coming. It's here, and so we need to take advantage of this moment now. And, I will say this, and I don't think anybody in this room will disagree. China is going full speed ahead to make sure that they can field cutting-edge AI and cutting-edge AVs in the field. We as a country need to do the same. So that's, I'd say, point one. Point two, the non-traditional defense contractors and dual-use companies, they're your friends. We can we do things differently, we move very quickly, and we can leverage private investment, and we can leverage work that we've done in the commercial space to move up that TRL ladder much, much faster. And so that said, try not to jerk us around, because in the end, we have boards of directors and investors who will say, wait a minute, this customer, they pay on time, they don't cut your funding, they're there when you need to, they can buy SaaS in a modern way, et cetera. Why should we be going with the military if they're jerking you around all the time? And I won't lie, we've loved our experience in a lot of ways, but we have had some very painful things, from approach cuts to other things to contracting squabbles to et cetera, that have made it very difficult on us to change
I'm going
the
to pull the
structure.
industry back as always. Now, I do want to take you, as I said, you're all the ecosystem, okay? Take the opportunity. So Q&A, it's your time.
Hey, thanks, guys. John Hernandez, Fort Sill, C5ISR, RTI, and PM-SWAR. So for the user community specifically, right? So you mentioned having a lot of, I guess, consternation with help that you need, right? So for me, I see courses that I think users should get involved in. I see working groups, I see, IPTs, all these things, and then I see demos, right? So where do you truly need, more touch points from the user community, whether it's, attending classes, whether it's, being involved in the program meetings for you, whether it's doing virtual prototyping with the industry, like where do you guys need the most help from the user community?
I'll jump on that. So from the user community, it's one, just understanding the process, and it's the process. Oh, everybody hates the freaking process, but the process is there and it's hard to get around it. The process would be making sure that your voice from a user community is represented in the user representative process, which is just the JSID's normal. I got to get my voice into the requirements documentation process, but also at the same time understand your warfighting function and who your PM and PEO is, because again, you're going to find folks like myself who are constantly going to the user base going, hey, what's your real problem? Because this is my requirement, and guess what? This requirement is not helpful because I'm not going to be able, it's this big. What do you really need? Because that's what they do. They create gigantic requirements and then go, here, PM, go figure it out. And then we're like, oh man, how are we actually going to satisfy the needs of the soldier? So on our side, is actually talking to you. So one, you have to make sure that your stuff is in this document, and then be super aggressive to your PM to figure out how to prioritize within that.
Quick question, Will Ryan from DIU. I fielded a question yesterday about kind of safety certification. We've talked about it a little bit today as well. We have to get things certified before it goes out and touches soldiers. And that's good to get it to operate on day one. What do we need to do to accelerate that process to make sure it operates on day two after we make contact with the enemy?
You stop, and I'm involved in several committees in safety. UT has a committee called Good Systems, analyzes heavily at all levels, misinformation, generative methods, probing models, physical levels of AI. We are, we're in the United States, right? Regulation is touchy. So kind of having a comprehensive sort of safety recommendation is kind of a hard thing. But we do have organizations that are very savvy. And one organization we're with is MITRE Corporation. There was somebody here. Is anybody from MITRE Corporation here? MITRE is wonderful about a deep knowledge of what standards exist. And right now, if you want to deploy autonomous systems, certain scenarios, maybe non-military scenarios, it's just there's no standards you can follow, right? So you're not going to get the certification that you need. So what you can help is to bring these organizations together, the people they really know in what can be proved, what can be certified, and existing actually certificates that exist out there that could be applied to DoD systems in terms of expectations and metrics. For instance, there's one called safety integrated levels, right, which is the number of failures per billions of hours, providing the infrastructure not only to produce models of reasoning, but models for safety and being able to project them into the future. Like you cannot prove that a robotics vehicle for 1 billion hours is not going to fail. The only way you can do it is take some data, put it in, develop a statistic model, and then project it into the future and say, from this statistic model perspective, it's going to fail only one time in 1 billion hours, right? So that's what we need to help, to bring those experts and to bring, again, infrastructure that allows us to scale safety. Thank you.
Maybe quickly, can I just jump on that? I'll be very fast because I'm, God knows, not a safety expert. But what I will say is modern solutions also need modern thoughts about how to prove safety. So whether that is safety case frameworks, I see my friend Mike Wagner from Edge Case Research, and some of the concepts built out in UL 4600, whether it's leveraging things like probabilistic risk assessments, which are used in the nuclear industry and aerospace and otherwise, to use math to help us put these things into concepts and really bound and understand risk. Whether it's, and Colonel Bernier said this, whether it's leveraging simulation platforms, right? This all should not be, let's take vehicles and drive them billions of miles. We can leverage these modern tools to prove safety in a modern way. And I know we've had really productive conversations with ATEC around that.
Good morning, gentlemen. CW4 Reggie Oliver, 166 Aviation Brigade, 1st Army Div West. So this question is primarily for Mr. Patel, but I certainly welcome any of the feedback from anybody on the panel. But so you brought up some issues about digital literacy and access to relevant information and data. So given the limited availability and understanding of technologies at the warfighter and user level, has there been any consideration of an agentic approach to data gathering? Specifically, could AI agents be trained on each organization's technical corpus, such as SOPs, AARs, and other documentation and relevant information about how they make decisions and what their specific workflows are to enhance user engagement and introduce edge technologies while keeping users actively involved in the process so you can get relevant data from the bottom up as well as cipher it from the top down? Thanks.
So if you have a CAC, if you have a common access card, I would encourage you to put that use case into our Army Data Catalog website that says, hey, I have a AI need and this is what it is, and now trigger the process. And now to answer the question, because I love that question. So yes, we do need that. We need people to say, hey, well, what are our needs? And then that triggers us, my office, to go talk to the organizations and the individuals to say, what are you trying to do? Where's the data? How do I get access to the data? How do I bring it into my environment to start doing that? What value are you trying to get out of solving that problem? So that, again, that triggers the process for us to get after it. That is step one in our AI process. Because again, going back to, maybe not even going back to, because you haven't heard me say this, but software is still awesome. Everything doesn't need AI. So we're trying to figure out, is this a software problem, or do I really want to invest AI in it because AI is expensive? AI needs a lot of infrastructure, a lot of enabling technologies, people, process. So before I start my AI journey, are we ready to do this together? So those are some of the things that we 100% think about Project Lynchman before we even start a project.
All right, so I'm John Smirka from DevCom GVSC. This is a question for Mr. Coleman. The single AI driver discussion really piqued my interest. Granted, you guys are still working on point-to-point navigation in off-road terrains, but how do you envision moving into tactical maneuver?
Yeah, I think it's a great question. I mean, the short answer is this is an ongoing conversation that we need to have with you all, as well as, again, with the kind of the warfighter community to understand exactly what they need. What I'd say is, we are not a GPS breadcrumb kind of company. The way that we've tried to build our system. So first of all, like, one of the fundamental differentiators for Kodiak is that we don't leverage HD maps in the way that traditional autonomous vehicle companies do, right? That made a lot of sense when you're trying to drive in downtown San Francisco, because the Transamerica building is always going to be there. And so if it'll shake a little bit, but it's not going to move. And so, if you're here and the Transamerica building is there, you can localize where you are. In addition, a heavy level of detail in a city makes a lot of sense. That thing on the corner is a fire hydrant, not a little kid with a black raincoat and a red hat on. A really important thing to know for you to be able to navigate through the world. For us, we, from the outset, said that doesn't make any sense from a highway perspective. Highways are inherently dynamic. They don't have fixed land points. You pop up construction lane shifts, et cetera. That's been all the more true in our work with the Army. Also true in our West Texas world. And so we built a system that needed to be able to effectively, we call it perception over priors. It needs to trust its eyes, not its memory. It's not, hey, what does my map say and where do I place myself on it, and then what do my sensors say? It is, what am I seeing? Great. Now, does the map I can use as added detail, but I don't need it in order to see. And so that was critical for us to be successful with y'all. And in that, what we said is, you can't call timeout in Ukraine and say, hey, I want to go map the environment. That goes without saying. And so instead, we've tried to leverage some satellite maps where somebody in the field can effectively draw a generalized path. Hey, here's what I want you to do, but the robot will still make dynamic determinations based on what it runs into. And so I think that is the underpinnings of where we need to go, but then we need a ton of input from you all. Hey, based on X stimuli, right? This is how we've trained it, right? You create classifiers, and those classifiers then lead to behavior predictions of the actors around you, and then you have a weighting system, right? Hey, here's the value of doing this, and here's the risk of doing this, and you make those determinations. We need your help with the weights a lot, and we certainly need to understand, if I classify the X, right, the smoke, the bomb, the whatever, what does that mean I then need to do as the reaction, and what's the behavior of that object?
So before I thank the panel, I want to take a 30-second now. I want to expand on something Sam said this morning. It is critical that the ecosystem doesn't stay quiet. It is critical. It's like Sam says, you feed that information that goes into organization at ARL, into application labs and all the other stuff. Because at the end of the day, I don't realize that from my side, as a member of the Army Science Board, this stuff also gets fed up to us. So when we get a complex challenge from them, it allows us as an independent agency to talk to the whole ecosystem. So just recently, we did an HMI. We just finished one on data-centric and other ones. But again, what I'm trying to say is, don't stay silent. Use these opportunities, use these events, voice what is needed so we can get the change, observations, or recommendations to our senior leaders to bring in this technology in the future. And to that, a round of applause for our great panel for today.
All right, everyone. We're going to be swapping out the panel right now, moving on to our next one.
I'm an hour and 20 minutes late to a board meeting.
As Ray said,
I'll call you.
hey, let us know, make noise, let us help you get your technology out there, because a lot of the times what we're finding out is even some of these companies that are killing it on LinkedIn, doing a lot of marketing, doing a lot of advertising, and then I talk to other DoD customers and they've never heard of you. So let us help you where we can. Let's take a couple minutes, just hang tight, they're re-miking up, and then we'll get going. All right, we're going to kick off about 2 minutes. 2 minutes. So if you can make your way back to your seats. All right, let's go ahead and make our way back to our seats. We're going to get this next panel going. All right. Let's make our way to our seats, folks. Seats. All right, who's tired of talking about trust with autonomy? Anybody? Let's make it. Who's been in an autonomous vehicle? Who's done it? Nobody's been in the vehicle. You've actually driven in it, rode in it. James over here. The Overland guys, for sure. Code 19, definitely. They have. Kodiak, I was there last week. Hey, we got the next panel. They're employing these capabilities right now. They're getting the communities to trust them. They're getting the customers that they're working with to trust their capabilities. And so they're going to elaborate how they're doing this and how they're employing it. So for our moderating this panel this morning is going to be David Michelson from the Defense Innovation Unit. He's the Director of Autonomy Portfolio. Next we have Lawrence Walters from Code 19 Racing, the CEO and co-founder. We've got Chris Mers, Director of Products for Overland AI. And then we got Michael Wagner from Edge Case Research, Chief Product Officer. So please give this panel a round of applause.
Hey, good morning, everyone, and thanks for letting us continue to talk to you guys about autonomy, and in this case, trusted autonomy. Real quick, we'll let everyone introduce themselves, and then I'll set this up and get us into our first batch of questions, and then towards the end, we'll hit into Q&A. So, Lawrence, please introduce yourself.
Yeah, thanks so much. So, Lawrence Walter, CEO, co-founder of Code 19 Racing. A little bit of personal background. Obviously, I'm not originally from the United States, but I did spend 22 years in active duty and reserve in the U.S. Army as an artilleryman and counterintelligence. And, we formed this world's first autonomous racing team just 18 months ago, and have just been really excited with the very rapid progress that we've been able to make. Very quickly putting together crack teams of race engineers and competing at the highest levels, right, against the top high-speed robotics labs in the world, right? Racing against them competitively and winning, right? Like our first race last year, we were the best rookie team, beat many of the other top international competitors, including China, which was we were very excited about. And now we're expanding. The world of autonomous racing is growing rapidly because motorsports has always been the proving ground for technology. And so many investors see, the racetrack and other types of racing, like drone racing, off-road racing, as a really exciting way, not only to advance the technology, but also to get the community at large, right? The users of the world that buy commercial autonomous products and hopefully will be demanding more robotics in the formations. So those end users, getting them to be comfortable with what the capabilities of autonomous racing autonomy can do through the lens of racing, right? If you can race vehicles and drones safely at very high speeds, eventually with humans on the track as well, then it's like the whole, you watch it on Sunday, you buy it on Monday, right? From the adage from the racing community. So we're really excited to play a role in that and promoting autonomy at large globally. And then especially two of our three co-founders are retired military. So we've always been excited at the dual use opportunities. And just thank you for being here in this panel to all the folks, because it's been an incredible learning experience. I already had a lot of knowledge, but connecting with other startups, other program managers, like we need to do more of this. The community needs to be talking more, and so we're excited to be part of that and help us all go faster.
Cool. Thanks, Lawrence. Chris? Yeah, awesome. So thanks for the opportunity to be on the panel. It's been great meeting you, Lawrence, and Mike, good to see you again. So I'm Chris Mers. I'm the Director of Product at Overland AI. And we're building advanced autonomous vehicle technology for defense to save soldiers' lives. Our tech enables an uncrewed ground vehicle, or UGV, to operate independently and intelligently in the most complex terrain. So think contested environments, GPS denied, those sorts of things. So personally, I've been at Overland AI going on a year now. I lead product here, work very closely with users, soldiers, to make our product and the user experience better and more intuitive. And before this, I was at Google working at Trust and Safety Engineering, and then spent some time in the Army. So I actually served with Dave for a little bit, and as an infantry officer and special operations officer. So pleasure to be here. Mike?
Yeah, thanks everyone. My name's Mike Wagner. I'm the Chief Product Officer at EdgeCase Research. Prior to EdgeCase, I was at Carnegie Mellon building autonomous robots back since the mid-90s. EdgeCase exists to try to make sophisticated technology safer. So what does that mean? It means we're not just talking about trust, but we're actually implementing tools to make AI and sophisticated systems trustworthy. And so on the commercial side of things, we just heard from Jordan and folks from the last panel about everything that's going on in the commercial space right now. In addition to seeing Waymos driving down the street, we now do have safety standards like UL 4600. There's a new standard that's a branch of that called UL 4601, which is for drones and aviation systems that's still in work. These are practical ways of proving trust and showing that the system is built at a high level of rigor. We're also working quite a bit in the defense world, especially with the Army. So we're the system safety partners for RCV, for XM30, for SMET. We work with a bunch of contractors that are developing these systems, and we're helping them be compliant with standards like MIL Standard 882E. And the cool thing about that is that I hope I'm not saying anything too controversial, but I guess I'm on a panel, so that's what we're here for. A standard like MIL Standard 882E is typically a very waterfall kind of process. It's very hard to know that by the time you get to the end of that process, that your autonomous or AI-driven system is going to receive the risk rating you want in context. There's a lot of traditional safety engineering that's just not compatible with the technologies that the Army needs today. So we're trying to modernize the process of being 882 conformant. We're not saying go and do something else, but we're saying here are some solutions about how you can get to your acceptable levels of safety that are compatible with AI and can keep up with a program. So we're working with like ARL, working on low TRL programs to make sure that they're not going to have a massive amount of technical debt once they start getting ready to field higher and higher TRL systems. And like I said, we're trying to keep up with modern AI techniques. So love to tell you a little bit more about that. But yeah, appreciate being on the panel.
Mike, we're here to make things like 882 Echo spicy. Like that's the point of a panel like this.
Yeah.
So, if we can't do that here, then we failed. So I appreciate that take. To kind of set us up a little bit to get into some of the questions, when we were all approached about doing this panel, part of the setup was, we know we need autonomous vehicles. We know they exist, they're out there, but we don't really have them yet in the Army. So what can we do about it? And as I was thinking about that prompt and that set of questions, I watched, again, the Unitree videos that I think a lot of people here have probably seen. I wasn't allowed to play it. Otherwise, we would have pulled it up. Their sizzle reel of all of their quadrupeds and their humanoid robotics and others doing all sorts of cool flips and things. And obviously, like, that's what they want us to see. However, it's indicative of where China is pushing investment. And
I personally think if the US government's not careful and if we don't take action now, we could see Unitree become a DJI. The same way DJI dominated the small drone market and we're still playing from behind. That could happen in the ground space. And I think that's probably existential for a lot of companies like yours to get priced out of the market or to have a competitor like China really dominate. And so what can we do then? What can the Army do in particular, since we're sitting here in Austin with AAL and AFC? What can we do to make the reality of autonomous vehicles occur faster within the Army? So, Mike, I think we'll go backwards in order here, and I'd love to start with you and your thoughts on that.
Sure. So again, we're talking a little bit about trust here in the context of this. I think traditionally, a lot of those processes that people use to try to gain trust in a system are very slow. And so you see the technology, of the autonomy itself, get demos ready, get even initial operations ready, and then there's a hesitation to actually accept them because they haven't passed muster in all these kind of old-fashioned ways. So again, what that requires is the ability to apply solid processes. It's not like we throw out systems engineering or safety engineering. We just have to make them better. We have to make them faster and more scalable. And so I think that's kind of the next frontier. And we are starting to see some answers from the commercial side because their parameters are different, but the technical goals are exactly the same.
Chris?
Yeah, Dave. So I think that's a great insight. You see competitor companies, near peer nations moving very fast in the field of robotics and autonomy, and it is concerning. It's not just concerning for us as a company. It's concerning for national security. We don't want to get left behind. So fully acknowledge that. Where I get nervous, and since we're on hot, spicy takes here on this panel, is I'm concerned about, like you said, safety processes taking too long. Not to call out any specific organization, but these things are kind of traditionally waterfall-y. And so I think the imperative is to work closely, both industry and government, program offices, all of this, to figure out a way to move faster, rapidly iterate. And I think instead of just admiring the problem here and just talking about it, what are some tactical things that could happen? I'm actually curious on your take on this, but I feel like there's an opportunity here to actually define a standard. There's a lot of learnings I think we heard on the last panel. Also, other folks brought it up. There's a lot of learnings from on-road driving that we can apply here in terms of safety arguments, reading from UL 4600, thinking through novel approaches to ADA2E, the military's risk assessment process and all that. And so I think once you define a standard, it allows companies like us to move quickly and build towards that standard and really create the teams to move fast in that environment. And then on top of that, I think there needs to be, some appetite to assume risk, right? Actually embrace risk. I think on day one, we heard from a lot of the soldiers up here, from really innovative units like Sandhill, 75th Ranger Regiment, acknowledging that they may get an 80% solution, and they're cool with that, right? They're gonna experiment, they're gonna break it, but that's how it moves faster. That's how it actually gets better. I think historically we may have seen some risk-adverse behaviors when it comes to adopting new technology. That it's a mindset shift, but I think it's absolutely critical to nail here. It'll take time, but I don't think we have that much time to work on it. Just some thoughts there.
Yeah, Lawrence?
Yeah, I think absolutely we have to acknowledge that China is a fierce competitor. And, in the way that technology innovation cycles go, you can leapfrog, right? So, a lot of our awesome legacy capabilities are going to be less and less relevant, and the Chinese are kind of jumping ahead on where they're going with robotics. So totally agree. We have to, I would think of it as investing in risk and listen to the warfighter, right? So we had the Ranger Regiment saying, well, it's limited. We've only got 2 drones. The opponents for the Rangers, right? The adversary they're going to be facing, we're assuming it's going to have hundreds of drones. So, or more, right? So how do we very rapidly, not bypass, but mitigate risk, but then get those units, the systems in their hands to experiment with immediately, and have the actual end user be intimately involved in the experimentation process, which I think is some things that some of our competitors, like commercial competitors, but companies that were sort of trying to follow the lead, right? More of the same. You see what happened with Overland and the DIU, investment that was leveraged with investor, and now they very rapidly, from the RACER DARPA program, now have a system that can be put in the hands of maneuver commanders. So more of the same, right? We want to learn the lessons, and like listen to the experts on safety as we're trying to bring some new capability and not duplicate what others are doing. I think there's the Army and DoD has a role to kind of not adjudicate that, but to help companies focus on a product roadmap that is scalable, that does have dual use commercial, right, and does not overlap. Of course, we're still competitors, right? But how can we be? I mean, just like on the racetrack, yes, we're racing against all these other countries, but in the paddock, as we're just trying to get these high-speed robots to work, we have to collaborate with each other. We have to share data, and so any way to facilitate that on the government side to help, high-growth venture-backed companies work together, be collaborative, go fast, and be engaged.
Mike, you look like you wanted to respond.
Yeah.
Yeah, there's so much here. So, I guess one message I want to make sure that we send is that it's not, the Army doesn't have to make a trade of safety, trust, reliability versus innovation. There are ways of achieving both, and I think it's very important to keep that as our goal. We mentioned China as a adversary. If we're going up against adversaries that don't follow any processes like this and are incentivized just to get stuff out the door, then we have a huge advantage, right? Because we all know the reason why we don't trust those demos is that what if you just tweaked that fire hydrant location or whatever? Like, would it still work? The answer is probably it wouldn't still work unless they followed a process. So it's very crucial that we keep these ideas like trust and safety and don't just use them as kind of like, negatives or think about them like barriers to innovation, but actually enablers. So that's kind of why we've tried to think about it. We take a very continuous approach to this, just like the development works. We call it DevSafeOps, of course. But the idea is like understand the risk in context. Do like very small assessments that trace all the way back to data and be able to say, okay, I may still have a lack of certainty in my risk estimate, but I'm okay with that. Like that's like where should I make an investment or where should I make a deployment? As a program manager, how can I do this in a way that's a little more responsible versus wild stuff? And I think that's the way these processes need to work.
Some thoughts I had as we were listening to the last panel, and as you guys are all talking, all three of you are like intimately involved in the product, whether it's through your title or the fact that like you're the CEO, co-founder, you've been doing this for a long time. Thinking about that, we've talked a lot about process as well. One of the things that kind of came to mind is like to be able to go a little faster, but to do this prudently and to ensure that you have the product that the end user wants. It feels like there may be room to do a lot of things in parallel rather than in sequence in the traditional defense acquisition system. And so I'd love to hear your guys' thoughts about that, as opposed to saying, hey, we're going to do this amount of time for market research, this amount of time for requirements writing, this amount of time, instead of going through different gates one after another. How do you guys think about product and building something with a parallel kind of process in the department as opposed to in sequence?
Well, I think that one thing you got to realize to succeed at that, you have to be okay with being wrong, right? Part of the reason why we have these phases is that it feels good. Like I'm an engineer too. Like I want to be able to have the time to finish all the work products, triple check them, be like super confident, look solid. But the benefit of being wrong sometimes, of course, is you learn things you didn't know. That's what our safety analysis is all about. We're constantly looking for hazards that you didn't think about up front. And you know what? That's okay. So, I think being able to accept that maybe you won't have the perfect solution is an important key to this parallel approach.
Yeah, so I think we're not really moving in parallel with like the government in this. We're just doing it because nothing really exists right now. So what I would say is we think about it in two buckets. So one, we think about building trust, and then we also think about earning trust. And I think those two things can be done in parallel, and that's what we do internally. So with building trust, this is a lot of like what we've been talking about in the safety realm. So we have like a core safety team of system engineers, safety engineers that ensure we're complying with, ADA 2E, and we're taking learnings from UL 4600 to create safety arguments and compile like the V&V data, the evidence claims, and all that, so we know that the system is acceptably safe in certain conditions. And so that's on the like the engineering side. And core to that, and in our belief, is we have a field-forward ethos. So we get the system out in the field, and we're regularly testing it under real-world conditions. So both functional and non-functional requirements are super important to measure and validate, and that's what we focus on. So while that's happening, we're also trying to earn trust at the same time with soldiers, the real end users of our product, if you will. And so this is where I think like there's huge opportunity to move fast and really like change the way we think about it. So we've been fortunate to have a lot of relationships with actual end user units or soldier units, which provides us touch points with them. And this is what I love to do, being a former soldier and then combining what I did in big tech is work on this user experience. So we heard a lot around like soldier-centered design, user-centric design type stuff from other panelists. We also prescribe to that ethos. And so this is really like putting our system in front of the users and letting them beat it up, right? And I think from there you start to expose all sorts of interesting things like edge cases, where it fails, how could this workflow be more intuitive? And I think really the end goal there is to make the system seamlessly integrate and be intuitive to the user. You don't want it to work against the soldier. You want it to work for the soldier. And so that's really like this portion of earning trust. And I think if you combine those two, you start to drive adoption. It is, an iterative process. It does take time, but that's how we think about it. And those two things are moving in parallel.
Yeah, so when we think about trust, there's many different stakeholders of trust, right? You have the program managers that we're trying to get to invest in our technologies. We have, in many ways, our race engineers, right? So we need our race engineers to trust that the machine that they're building can go faster and that they know where the edge of its performance envelope is. And then, from the military perspective, you have like the end user, right? The soldiers that are actually need to trust these systems. And so we have felt from the beginning in our world of autonomous racing, like the fans are also like very important. So we need to have trust with the fans as well that this is an enduring form of motorsports and that they can understand what's going on with the technology. And so to try and get at all of those trust use cases, we've been very focused on what we call like explainable AI. And so that's, taking these very complex robot operating systems and all the nodes and parameters and mathematical, matrix mathematics that's happening inside these systems and, through a LLM kind of RAG layer, allow all of those stakeholders to be able to interface with the technology in a natural way, like through language and with some kind of dynamic graphical interfaces as well. And we do that, so the race engineers can interrogate like the robot, right? Like this is the goal. We're almost at that point where, because for us, like track time is like very expensive, very critical, like collecting that data. It's the same way any field experiment in the military. And so we want to be able to iterate like in those experimental times on track or in the field or wherever as rapidly as possible. So we've been intentional about creating like a human interface to the robot system. And same for fans, and that fan has a interface, like is a strategic goal there to get people more comfortable with autonomy. And then the end users, right? The ones that are actually, going to be taking these high-speed robots into very difficult, complex battlefield environments. They, when you're under a high cognitive load, right? Like we put autonomous vehicles against humans on the racetrack and drones. And when you're piloting or driving a race car, right? And you're cognitive, you're not only do you have to drive the car really fast and not crash, but there's like adversaries that you're going against. And so the cognitive load for a human pilot or driver is very high. And so then being able to rapidly experiment with how our drivers, which, is correlates to like a soldier, how they are going to need and want to naturally communicate with robots as they're performing their missions, right? On the racetrack, it's to win, and it's the same on the battlefield, right? Winning.
Yeah, Chris, you said something that reminded me
of an experience I had when we were serving together in the Rangers, and it was adoption. I remember we had just received some new drones, and I got really excited. I was like, this is going to be so cool. So met with our senior enlisted, our first sergeant, and I said, hey, let's get the guys to go test this thing out and like figure out, you know, what's great about it, what works, and how they think we can employ it. And an hour later, and after getting a nasty phone call from our boss because our guys were flying it places they shouldn't be flying it. Different story. But we went out there and we asked them what they thought, and they just said, sir, this thing sucks. Like, it's horrible. And the point of the story is, I trusted that the thing we received had been through all the safety certifications. I trusted that it was going to work when you hit this button, you know, that'll climb altitude, that'll go left, it'll go right, it'll point the camera at the thing you want it to. I trusted that it met all of those requirements. But it didn't, adoption was an absolute failure. Like, it was a complete flop. We locked the thing up, put it in storage, and we only looked at it when we were required to do inventories. So the question I have for you guys, really, and Chris, I'll start with you, is how do you thread the needle of achieving trust and adoption so that you don't over-engineer towards a safety case or towards trust, and then it shows up and the soldiers are like, this thing is horrible? Yeah, no, that great story. I'm sure many in the crowd have stories of like the $4,000 paperweight that sits in a Connex and gathers dust, and then some poor lieutenant's got to inventory it. So I can definitely empathize. Yeah, so I actually want to like zoom up a little bit because we've talked a lot about trust, but we haven't like defined what it means. So I'll give like my layman's version of it. I'm sure there's like multiple definitions, but you know, I think simply you could call trust like, does the system do what you expect it to do and like not maybe hurt you or kill you while doing it, right? So if I use that definition, I think that implies in order for that to exist, a couple things need to be present, right? So like one, you need to like understand and know what the capabilities and boundaries of your system are and be able to communicate that to whomever is using it, right? So in your instance, right, I don't think anyone told you that like maybe this thing won't like fly up when you hit the button or you didn't do the right sequence of things, right? So that portion I think is super critical to nail. The second thing is it needs to be reliable. You know, reliability includes safety. It includes the thing just not blowing up on its own when you thought it would be working. Because the reality is, you know, these systems are going to be put in the harshest environments, the most complex terrain, and the soldiers are going to stake their lives on the use of it. So it needs to be reliable when it matters. And then finally, I think it needs to be like, I keep hitting on this, but like intuitive and easy to use and very natural and integrated into sort of workflows. And so I think, you know, using that definition leads to these three things that we're focused on building. And you know, the only way I think you get better at iterating on those three things is working closely with the partner soldiers and the users, right? And so, yeah, we're trying not to be the $4,000 paperweight in the back of the Codex. Mike?
You know, at some point it makes sense to have all that process, but we need to think about a little bit about what it's for. And I think about Nassim Taleb and his book Anti-Fragile, if you guys have read that. In that book, which is I think pretty old now, he talks about anti-fragility, and he talks about robustness actually being the opposite of anti-fragility. And what he was trying to get at there is that you can really engineer a system super well for some intended set of requirements. You can over-engineer it in a way to actually make it so that it won't, like it simply won't work. The better way to approach it is to think of the whole process, not just that drone, but the whole process as anti-fragile, which means it gets stronger when it gets beat up a little bit. So what does that mean technically? Well, technically, you know, one example of that, there's a bunch of different things that we're talking about with iterative product development. But when it comes to safety and maybe trust, one of the things that's I think anti-fragile about UL 4600 and about DevSafeOps is that you're counting on monitoring out in usage. So you're saying, okay, I've done a good job before I take that drone and ship it out to you guys. But I'm also making sure that I'm keeping tabs on it so that, you know, I can make it safe without over-engineering it and making it maybe not useful enough for what you guys needed it to actually do. And so, you know, hey, if you're not flying 1,000 of them immediately. And if you're able to get reports back and the development cycle is fast enough to respond to those, then we can build an anti-fragile, maybe like acquisition program or something that is able to make updates to that and learn as you guys are like, this sucks, and hey, it actually did, one of them did blow up or whatever. Like you can feed back the loop on that to make an anti-fragile system.
Morris?
Yeah, so there's first of all like so much information from this event, and I see a lot of things going really well and a lot of areas where we need more innovation. And then I think there is a willingness to say, because the Army's asking this question, right? Like what can we do? What else can we do to go faster and be better? From our perspective, like because we've seen it firsthand, like the power of competition and what small teams of engineers and innovators can do when there's a competitive goal, right? And that inspiration to work hard because you want to win and there's a prize at the end. How do we take that mindset like inside our formations? So there's some early movements on this with the National Drone Association. I think they're having a drone racing team July 4th down in Orlando. But it's the Marine Corps has a team. The Army, we don't have a FPV drone racing team yet. So what's the Army gonna do, right? Like the fit to fight pilots, like we're gonna need a lot of those inside our brigades, and then we have to, that's the base, that's the human base, and then we build the autonomous systems that can complement that to go around it. But, let's challenge the brigades, right? Like they should all have a racing team, in my opinion. A drone racing, maybe ground as well. The Army should set the competitive rules, put some resources behind it, connect the industry partners, and let's see what each brigade can do. Let the soldiers innovate. I mean, you can build a drone now with just commercial off-the-shelf tech that you can fly FPV and can run autonomously, for $5K, right? You want a wire system, you got to add a little bit for that. But let's put all of these tools and let the soldiers at the brigade level innovate and do that in a way that's competitive, because we know we have a fierce competitor in China, but I really want to beat that other brigade, right? So get the commander's intent, into the formation of we got to win, and doing that through a sporting activity that has great dual use. I think that's how we can create the cultural change in the maneuver formations that we need.
I really like that. It makes me want to go back in the Army and be like the FPV drone racing team.
Yeah, seriously.
Lead that
OIC.
right?
Yeah, be the OIC.
Yeah,
Sign
that'd
me
be a
up.
lot of fun. I think that leads into, the last question I'll ask before we get into Q&A with the audience is, Lawrence, you just kind of hit on some of it. It's like, okay, we just talked a lot about different process, about a lot of different tools, some systems engineering. To go back to the original question, what can the Army do? At the tactical level, at the practice level, what are some things that we can do? Is we talked about a lot of work too, in ensuring that we have robust, reliable, safe systems that get adopted. But how do we do that and not wait a decade to field something? Because again, Lawrence, to what you just referenced, we have fierce competitors out there, not just China, but there's also Russia. They're fielding systems now that they exist in Ukraine, they're in combat, and they're learning. We're studying. So how can we close some of that gap, and what can the Army do? I think we'll go back over to Mike to start that and then work our way back down.
Well, I hate to talk about requirements because there's probably a bunch of different ways around it, but I do think that specifying expectations on safety, reliability, and trust in these kind of systems is important. Doing that right is really critical. So again, updating the idea that at some point you're going to have some waterfall safety process and turning it into something that's actually requested to be done early on, and that's, I wouldn't say funded, because I don't want to ask for a lot of extra money for it. I want to do it right with more efficient tools up front. So I think having the acquisition side of the house understand what that means is really important, because I think the expectations are quite different. And we now have some technical guidelines like UL 4600, different tools, different processes that are running on the commercial side right now that we could, workshop for the acquisition community so that they can see sort of how these things have succeeded in commercial applications.
No, it's a great question. I think I'll not say stuff about standards and Mike covered all that. Hot take here. I think we should have more just bottom-up grassroots innovation. So what tactically that could mean is, units have teams that are working with new novel systems. And I don't think this is like consistent across the Army. Some units are good at it, some units aren't, some units haven't tried things, some units have. Like Sandhills has gone all in on breaching. They're really like paving the way in that arena. And I think that's a model worth studying, because what that allows us to do is provide more forums for new tech like Code 19, to be actually put into the hands of soldiers and experimented and iterated on. And I think it's in the spirit of transformation and contact and all these other bigger initiatives that the Army has right now. So why not build on that grassroots bottom-up innovation? I don't think anybody, at least from the defense startup place, would be opposed to that, right? Because it's more touch points, it's more reps, and that's like one of the biggest things you hear from industry is like, we just want to get our tech out to the hands of the soldiers. So I think that will naturally lend to informing requirements, discovering new things that we just don't know. But the only way to do it is just to keep iterating at a rapid pace.
Before Lawrence, as you guys talk about standards and requirements, it also feels like maybe this is an experience I had with drones of like, a drone's not a Swiss Army knife. Could there be more focus on either an ODD, an operational design domain, or design reference mission to help get to a specific use case faster to get out there and experiment? How has that been in your experience?
Yeah, so from our perspective, we love working with end users. I talk to soldiers all the time. That's part of my job, is just interviewing folks and trying to understand what the con ops that soldiers want to execute and do look like, so we can build a better solution. And so from our perspective, it's actually super helpful, because we hear like, hey, could your system do this, right? Do that. Does that widget turn that way or that way? Could I do this and whatever? So, what all that is feedback that points to a broader problem set or a pain point or a need that we define as like an opportunity space that really helps focus the design and the engineering to achieve. And so our experience has been very good, and we just want more of that, I think.
The ODD definitely matters in making things possible. So from commercial trucking, we heard about driving around in the Permian Basin. Picking that ODD is probably very important for Kodiak to be able to have a completely reliable system. Other kinds of ODDs and use cases that have been successful involve like convoying. So you limit the scope of the autonomy to just following the vehicle in front. Those kind of things are very important design decisions up front. The other thing I thought of, and I feel like this is valid, is that at some point the standard mission might be updated too, right? So there's both the product that you're building and kind of the way you're using it. And sure, you start as a base case, like I want to put the drone into what I'm already doing today. But if the drone is successful and shows promise, then maybe you adjust what you're doing, and that would be to everyone's benefit.
Yeah, I will say the ODDs are not clearly defined right now too, right? I think there's opportunity for that, right?
Yeah.
So that's something I think involves more conversation and collaboration.
Well, and I think there's, on the previous panel, there was a comment from a gentleman, I think it was Kodiak, that said the autonomy capabilities are here now.
Yeah.
And their capabilities are increasing very rapidly. And that's, only likely to accelerate. And so, from a mission engineering standpoint, robotics, what capabilities they can deliver commanders on the battlefield, those are also going to rapidly progress. And so I think that this cycle of engagement between the end user and the industry partners and all the other people that make these systems safe and trusted where they can be fielded, that's going to be critical. And then the other piece that I wanted to just talk about was the interoperability with our international partners. So, most of these wicked hard build problems that we're facing around the world, we're not going to be fighting alone. And so, how in those kind of congested battle spaces, how is our robotic enabled maneuver going to be interoperable with our partners? And on the racetrack, we see that, we see that the culture and the engineering philosophies, from the different teams, different countries, there's differences there, right? You could call it a personality of the AI driver if you want, every country has a different set of requirements and capabilities, and so making sure that we're thinking about that and we're looking at ways that that we can machine to machine to human to machine, and then those those units of employment also being able to communicate rapidly with international partners, like a V to X, right? But it's international V to X.
All right, I think we've got a little time for some questions and answers. Sir.
So we build models, engines and models. The one thing we don't have access to, and this is a DoD-wide thing, it's an industry-wide thing too. So I'll state this in the form of a statement and then turn it into a question. And that is, we want access to level 9 maintainers, not level 3 maintainers, to get our models trustworthy. To correct that model, to train that model, we want the best. The hardest people to get are the best. At some point, there needs to be this cultural change where if you're at that level, you're also a trainer of models. You're a resource. So the question is, how is that going on the cultural side in the DoD to adopt that mentality? Because that's trustworthiness is going to come out of that in anything that's done. Second is related, and that is, but it's a very philosophical question, and that is, do we want more sensors or do we want less sensors that do more?
Anyone want to jump on either of those?
I mean, I can't speak to the DoD on the first question, but on the sensor question, I can riff on that. So, in our super formula race car, we have like all of the sensors, right? We have 3 LiDARs, 7 cameras, like radars, everything. We're fusing all of that data together, right? And it's a workload, but we're trying to, drive these vehicles 200 miles an hour, right? So every piece of sensor data, we're not constrained on the compute. But, when you start looking at like battlefield applications, size, weight, and power, like really matters, right? So it's not, you just need the right sensors for the mission, right? For the robot. And there's questions there about, interoperability, like hot swapping of sensors, like how modular and customizable, like in the field, do we want our robots to be, right? On some missions, like a LiDAR might be fine, right? It's an active sensor. But if you're preparing for something where you may be in contact, you might not want or need that LiDAR sensor. And so, the ability to tailor to the specific needs while also looking at how does the military sustain all of these different heterogeneous systems. It's a tough challenge. And the sensor tech, I think somebody else is advancing very rapidly.
Yeah.
So what you might want today, like next year, there's a lot of new stuff coming. So.
Yeah, Jordan in the last call or the last panel, excuse me, I'm stuck on Zoom. The last panel talked about probabilistic risk analysis. So that's something that we do a lot. So we build a risk model of an autonomous vehicle stack, and then we say, hey, where are the kind of bottlenecks in reliability? And usually sensor models, so perception models, ATR, object detection, whatever, tend to be the pinch points in those PRAs. And so from a perspective of trust and safety, we tend to suggest looking at more diverse sensors so that you can get higher levels of safety and reliability. But obviously that's at odds with building the vehicle, right?
Yeah. So I just want to clarify the question. Do you mean like sensors on the vehicle or like sensors in the battlefield? Like more or less, what do you?
Both.
Both. Okay.
And I understand it's different.
Yeah. So you answered sort of on the like platform side, more or less sensors. I think it's a debate too, like passive, active, these types of things. So I'll answer the battlefield question, and then I'll leave the DoD stuff to Dave, right? So, yeah, I mean, I think like just piling more sensors on the battlefield without the right infrastructure to, accept and process that data and inform decisions doesn't seem like it makes sense, right? Like, so what if you have all these streams if you're not going to use it, right? There's already a ton of just unstructured data that's collected and thrown off that could be useful, but, It isn't right now because we just don't have the mechanisms to work with it, right? So I think like those things need to move in parallel. I think we heard some stuff around infrastructure and then in the previous panel, totally agree. Like you need those mechanisms to process it, whether that's like an ML ops type pipeline or something to really make use of all that. But I do think like, you know, in the future, the battlefield will proliferate with sensors, right? You know, everything will be seen, sensed, and you have to be able to operate in that environment and then use that to your advantage. So anyway, don't pile on without the infrastructure.
I'll take real quick the privilege of, since I'm here, and I, like Chris, you're right, I am in the government. A privilege I have at DIU is I get to see the joint force. I get to see across the services and all of the autonomy programs in the DoD. I have personally been in the assessments for all of the autonomous systems that we're looking at for major initiatives. Like I've gotten to see a pretty broad view of the department. And I say that because what I'm going to say pains me a lot as a former soldier. The Army is not the best at providing access to those experts to help train models and to train systems. They're not. The Navy is. The Navy has done a lot to stand up squadrons of different types for their uncrewed systems, and has poured in a lot of resources into the .mil PFP portion into understanding all of the different needs that are there. You know, for example, you know, it was like a year and a half ago, we were showing some uncrewed underwater vessels to sailors, and they're like, I have nowhere, this is awesome, but I have nowhere to put this 24-foot boat. You know, look at this yard, I have nowhere to put it. And the Navy, I mean, that's just one easy example, and the Navy has leaned in to ensure like facilities are there, maintenance is there, their organizations are set up, training, everything. The Navy, from an institutional perspective, I'll provide that caveat, has really leaned in on it. I think you see a lot of brigades in particular and some units within the Army that have done a really good job of taking initiative to try to figure it out, but then you run into a lot of challenges of, you know, you could have 40 disparate types of things across all the brigades, and none of them actually end up working together when they have to come together in combat. But the Navy has provided, I think, a really good model of how to lean in on some of those areas.
Doran Michaels, Defentex. We make platforms. David, question for you. I'm contemplating parallels. Like the drone landscape is kind of a wilderness frontier, and regardless of its, you know, original plan, whatever that might have been, DIU has become like the de facto administrator and curator and adjudicator of that landscape at the national level. So kind of two questions for you. Is there such a thing, do you think, as blue autonomy? And then secondly, do you see DIU kind of falling into the role of being the adjudicator of blue autonomy?
I do not want to be an adjudicator for anything for the department. We want to enable the services, the combatant commands, and the components to be able to go out and scale and do what they want. Our job is to accelerate the adoption of commercial technology and commercially derived technology, and to help bridge all of those gaps, whatever they may be. We're there to knock down those walls. You referenced Blue UAS. I've seen it from the inception. When I was still active duty, I was a warfighter in residence with DIU when the whole thing first stood up, and now that's within our portfolio. So we've gotten to see it. We never intended to become that arbitrator, if you will, around drones. Maybe oversharing a bit, but I think it's worth talking about as we've attempted to transition that into other parts of the department multiple times to no success, unfortunately. And I think we're at a point now where, yeah, it's ours. Like, we own it, and we acknowledge it, and we want to do more. We've actually responded to a lot of inquiries from our partners in government on what we can do and get away from being perceived potentially as gatekeepers to being more in a compliance verification mode. So instead of saying, okay, we can only have 20 or so drones on the cleared list at a time, we want to be able to make it open. If you meet these standards, like, you're on it. Then it's on you to go out and you can do whatever BD you need to. You can go get your own ATOs, which is a pain in the ass, and I fully acknowledge that. But we also have limited capacity where we can do that. So we can't write the ATOs for every drone for everyone in the department. Like, that's just unfeasible. So yeah, we want to get away from that. We want to pathfind. We want to show this model to others and let them adopt it. We'd love to see the Army pick up and run with a lot of these capabilities on their own. We have playbooks we're happy to deliver them. We have bodies of evidence for everything that we've looked at. If anyone on the AO side wants to get in touch with us, like, we're happy to share all of that. So to the blue autonomy piece, that's an excellent question. We'll have to see kind of, I think, where intent from different parts of the department and the Hill will come from. Because again, we don't want to be the owners of something like that, but we want to be able to bring those capabilities into the department and then let the components scale those as they meet their mission needs.
I think it's encouraging, though, that the innovation unit, right, for all of DoD is responsible for that. That's a clear signal, I think, to industry that government wants to be innovative and wants, to have standards for safety and assurance, but is willing to push the limits, right?
Yeah.
That's the...
Yeah, it's a privilege to be here. I've been actually talking about this a lot lately. Part of Ash Carter's vision for DIU when it stood up was to work ourselves out of a job. That was the point. Like, it's not so that DIU would get this massive size and scale. Like, we love the fact that Congress gave us a super healthy budget and that we're able to go work with all of our partners, the Army, the Navy, the Air Force, everyone, to accelerate the adoption for commercial technology. But Ash's vision, and I was lucky enough to have gotten to know him a little bit, was never for DIU to own that in perpetuity. It was to be able to see a robust ecosystem where we're teaching to fish, not fishing for everybody. Other questions? Yeah.
Thanks for your insights on the panel. Elizabeth Mezzacappa from DevCom Armament Center, Tactical Behavior Research Lab. So our lab was tasked in the last year and a half to look at trust from soldiers, so to get soldiers' responses to AI and autonomous, particularly weapon systems. So we were tasked with developing a metric or measure of trust from soldiers in weapon systems. Throughout the data collection, one stat that came out from the data was that there's a fair amount of soldiers that will not use such a system unless it's 90 to 100% accurate in identifying friend or civilian. So I would ask, what's your response to that? Is there something different about thresholds we set for weapons in AI? Is it something achievable? Are we close to that? Thanks.
Well, it's not always comparing, one accuracy number to the next, but I think it's important to have the perspective of what's called positive risk balance. So where are we today? How accurate is the process today? That's not always measured, which can be a challenge. So then people fixate on a particular number for the autonomy or the autonomous system itself. I think that's one big point that we need to overcome. I guess the second point that's related to what you said is that there has been quite a bit of work on how you define metrics for justifying the trust in a system. And so it might be that, hey, if this has passed through a number of different gates already and been certified in certain ways, that may be a tool in the toolbox as well. Yes. Absolutely. Yes, that's right.
Yeah, I think that you need to get the soldiers in as close, in force-on-force maneuver exercises and exercising, like, okay, if I have, it could be notional, could be an experiment. If I had this kinetic lethal capability, like, here's the difference it's going to make for me on the battlefield. And maybe, as you do that, the end user may be comfortable with less risk, right? Because on a battlefield against a near-peer adversary, it's not like the GWAP where there's going to be a lot of civilians and that kind of stuff, right? Your lanes and your phase lines are going to be pretty clear. The battlefields are messy, but I think you just have to simulate it, first digitally, and then as quickly as possible get soldiers using those types of capabilities. Not just I don't know what your research was, but not just kind of questionnaires, but actually probing them after they've been in the field with that.
they're actually in-field exercises working with these types of systems. So we get the RAS platoon as well. So
What size of unit was in these exercises? I'm curious.
up to platoon. It was, we had different
So
data
very
collections.
tactical exercise, not at the operational level where you might have bigger maneuver units.
Up to company level. Day, night, yeah, that type.
So, yeah, it sounds like your study aligns pretty well with my layman's definition of trust, right? Like, does the thing do what it's supposed to do, not kill me or my buddies, while I'm using it? And so, first of all, I'll say we're not making autonomous weapon systems, so slightly different context and domain there. But I would agree with you, right? Like, it's the same thing with any piece of equipment that gets issued to a soldier. I feel like soldiers are naturally skeptical about things, and they're not going to trust it until they actually use it. And once they use it and understand the boundaries of what it can and can't do and how to employ it, then they start to figure out ways to manage the risk on the battlefield. So, as an example, indirect fires can easily cause friendly casualties, but we mitigate that risk by using graphic control measures and battle space management, and we know when to employ it and when not to. And yes, accidents do occur, but there is a system in place to manage that. And so I feel like there's an opportunity to use a similar approach with autonomous systems. So that it can operate forward of the line of troops, for instance, where there are no friendlies, right? And that's, by the way, that's a great place for robots to operate, right? Where things are dirty, dull, and dangerous, and you don't necessarily want to put humans in those positions, right? So not surprising that I hear those results, but I also think there are ways to mitigate it and ways to operate around that and also build that trust.
I think we're at time. Unless we have time for one more. Yeah, let's do one more question.
Aaron Kane from BH Sensors. I emphasize that, but I'd like to go back to what two gentlemen said a little while back. Building trust is always a difficult problem, and particularly with sensors, the view is, and I'd like to get your comments on it, the view is typically where you sensorize the hell out of something. You take the data and then you extract from the data what you need and play on that. The cognitive overload that you get and the like is important. We found, and working with RCV sustainment and what we developed, is if you turn the question around, it becomes much more solvable in that don't ask sensorizing everything, but ask the question, what is the consequence of not sensorizing a particular aspect of it? And you'll find, particularly with us, when we did the track and suspension system, that we went from probably 20 sensors down to about 3 that are needed to determine what the trust value is and how well the track and suspension system works. So if the mindset is switched as to what is your consequence of not getting your sensor data, the sensor overload and the sensor requirements become that much less, and you get much more focused, and you build that trust level where, the soldiers, if you tell them bolt number 6 is no good, and they go out and they check it, and bolt number 6 is fine, that's it, they throw it away. Yeah. But if you tell them the left side of the vehicle has a problem, go check your bolts.
Any quick responses? I was just going to add there are also a lot of benefits to sensors that human systems don't have. So speed to identification and stuff like that, which are maybe additional dimensions beyond just accuracy. I think that's a great perspective. What benefits do we get out of adding these sensors as well?
Yeah, I think sensors also, they have a financial cost. And so as we're looking at, less sensors is lower cost and likely more attritable. A lot of ground systems, need lots of sensors to go fast, like Overland's doing on the ground. But in the aerial space, it's, not many deformable objects. And so your navigation and planning, it's much easier. And so we're flying drones now with just a mono camera, and so we just need a single sensor and maybe some accelerometers and whatnot as well. But it just depends on the mission and the economics of what you're trying to build. And
Yeah, I agree. Use what you need to solve the problem.
Well, thank you to AAL and the Army for letting us talk for a little over an hour and for the great questions. Thank you to you three as well for a great conversation. I've really enjoyed all the prep sessions and everything in the conversation today, so thanks for all your insights. And I think we're the last thing before lunch, but I'll hand it over back to you guys. So thank you.
If we give our panelists a round of applause, please. Couple announcements. Again, hey, it's not over. We still got the work